Hello there and welcome to the Science for Sleep. Tonight, we are diving into the vast, mysterious, and soothing world of whales, the ocean's largest and most extraordinary mammals. These majestic beings are larger than dinosaurs, older than human cities, and more complex than almost any other creature alive today. Whales breathe air like we do, yet spend their entire lives in a realm ruled by pressure, cold, sound, and secrets. Their hearts are as big as small cars, their voices can ripple across entire oceans, and their memories stretch across generations like threads woven through time. Some whales live for over 200 years, witnessing centuries of change, while others dive deeper than any human submarine could ever reach. They sing haunting songs that echo for miles, strategize while hunting, care for their young with astonishing tenderness, and even alter the chemistry of the sea with each breath. Whales are not just animals. They are living worlds, vast, intelligent, emotional universes contained in flesh and fin. Once, humanity hunted them relentlessly, driven by greed for oil and meat. But now, the tide has turned. We listen to them, study them, protect them, and follow them across thousands of miles of open water, still uncertain of all the things they know. For now, take a deep breath, let the noise of your day fall away, and allow your thoughts to drift into the calm blue expanse of the ocean as we begin this journey into their world. Long before whales ever swam through the sea, their ancestors walked upon the land. It's a story that stretches back millions of years, to a time when small, four-legged mammals roamed the riverbanks and coastlines of ancient Earth. These early creatures had fur, hooves, and nostrils positioned at the front of their snouts, much like small deer or modern-day tapirs. Over time, some of these animals began spending more time in the water, chasing fish, cooling off, or escaping predators. Gradually, evolution shaped them into something new. Their legs transformed into flippers, their bodies lengthened into sleek torpedoes of muscle, and their nostrils migrated to the top of their heads, forming blowholes. Fossil evidence has revealed the incredible truth of this transformation, with bones showing both hooves and webbed feet, bridging the worlds of land and sea. Even today, whales still carry tiny relics of their terrestrial past deep within their bodies, small, hidden pelvic bones buried in muscle, serving no function but whispering of a time when their ancestors once walked. Every time a whale glides through the water, it is finishing a journey that began on land and ended in the deepest reaches of the ocean. Among these magnificent creatures, one stands supreme, the blue whale, the largest animal to have ever lived on Earth. Not even the mightiest dinosaurs could rival its size. This living titan can grow to lengths exceeding 3 school buses and can weigh more than 300,000 pounds, heavier than any creature known in history. Its massive body is supported by the buoyancy of seawater, which allows such extraordinary size without the crushing strain of gravity. Each day during feeding season, a single blue whale consumes nearly 4 tons of krill, tiny shrimp-like animals that fill the ocean like drifting clouds. Its appetite fuels the tremendous energy required to move such a massive being, and each slow, thunderous beat of its heart sends oxygen-rich blood coursing through its colossal body. That heart, larger than a small car and heavier than a grand piano, beats only a few times each minute, sometimes just once every 10 seconds, with a sound so deep and resonant it can be heard 2 miles away. Its arteries are so wide that a small child could crawl through them, and when the whale dives deep beneath the surface, its heart slows even more to conserve oxygen. Whales have blood specially adapted to store far more oxygen than that of land mammals, allowing them to dive for extraordinary lengths of time in the cold, dark world far below sunlight's reach. It is one of nature's greatest miracles, that such immense life can move so gracefully and breathe so deliberately within the ocean's vast blue heart. Yet despite their size, what makes whales most mysterious is their voices. Humpback whales, in particular, are renowned for their long, haunting songs, compositions of chirps, squeaks, wails, and deep moans that can last for hours. Only males sing these complex melodies, and each population has its own distinctive tune, passed down and modified through generations. What astonishes scientists is that these songs evolve over time. A pattern sung one year may gradually change, becoming a new song the next, an oceanic symphony constantly rewriting itself. These vocal performances are thought to play roles in courtship or communication, though the exact purpose remains uncertain. What is known is that whales learn songs from one another, and popular tunes can spread across entire ocean regions, much like hit songs ripple through human culture. It's one of the most astonishing examples. A whale's voice is so powerful that it can travel across entire ocean basins. Sound moves differently through water, faster and farther than through air, and deep in certain parts of the sea. Low-frequency sounds can journey thousands of miles without losing strength. This means that a whale singing near Africa might be heard by another near South America. Many whales have evolved to use these deep, low-pitched sounds to stay connected across vast distances, forming a hidden network of communication that links oceans. Their voices may share information about food, migration, or even companionship. Most of these frequencies lie below the range of human hearing, so we can only detect them using special hydrophones. Beneath the waves, an invisible world of sound surrounds us, a continuous conversation between the ocean's giants. Some of these whales possess another extraordinary ability, the power to hold their breath for hours. While humans struggle to last even a few minutes, certain whales, such as the Cuvier's beaked whale and sperm whale, can stay submerged for more than 2 hours without surfacing. Their bodies are marvels of adaptation. Their blood and muscles are packed with proteins that bind oxygen, and their hearts can slow dramatically during dives to make that oxygen last. They even redirect blood flow away from non-essential organs, preserving it for the brain and heart during the long, cold descent into the deep. Down there, where light never reaches and pressure builds to bone-crushing levels, they glide silently in search of prey like squid or fish. When they finally return to the surface, the sudden, thunderous exhalation, the iconic blow, releases the built-up carbon dioxide before they take in another great breath of life. The record for the deepest dive ever recorded belongs to the Cuvier's beaked whale, a species capable of plunging more than 10,000 feet below the surface, deeper than most submarines can safely travel. At such depths, the pressure could crush unprotected human lungs and bones, yet whales have evolved astonishing physical mechanisms to endure it. Their rib cages fold inward, allowing their lungs to collapse safely. Their bodies store oxygen in muscles and blood rather than air pockets. They can temporarily shut down parts of their organs to save energy, using echolocation clicks to navigate and hunt in total darkness. These dives are not occasional feats. They are routine, daily occurrences for many deep diving whales. The ability to inhabit such an extreme world makes them some of the most extraordinary creatures on Earth. Equally fascinating is how whales sleep. Sperm whales, for example, do not lie horizontally like fish or float aimlessly. Instead, they sleep vertically, suspended motionless in the water, with their heads pointed toward the surface and their tails hanging below. Groups of them drift together in silence, looking like a forest of living pillars. They rest for brief periods, usually 20 minutes or less, before waking to breathe or dive again. This upright posture may help them stay alert, allowing their blowholes to remain close to the surface for quick breathing. It also makes them less vulnerable to predators. For years, scientists had no idea whales slept this way until rare underwater footage captured a pod of sperm whales in perfect stillness, revealing a tranquil, haunting beauty in their rest, a reminder that even the ocean's giants must dream. But whales are not just gentle giants, they are also skillful hunters and strategists. Humpback whales, for instance, display one of the most fascinating forms of group hunting ever observed, the bubble net feeding technique. In this breathtaking display of teamwork, several whales dive beneath a school of fish and begin releasing streams of bubbles in a rising spiral, creating a net of shimmering air that traps their prey. As they circle upward, the whales coordinate their movements, driving fish toward the center of the ring. Then, in perfect unison, they surge upward through the column of bubbles, mouths wide open, engulfing thousands of fish in a single powerful lunge. The precision and cooperation required for bubble net feeding are extraordinary, almost like an underwater ballet. Each whale has a specific role, whether releasing bubbles, making loud calls to herd fish, or timing the collective ascent. This behavior is learned, not instinctive, passed down through generations like a shared cultural art form. It shows that whales are not only intelligent but capable of complex collaboration and social communication rarely seen in non-human species. Whales also play an unexpected role in shaping the planet's ecosystem. Every breath they take, every dive they make, influences the ocean itself. When they feed in deep waters and return to the surface to exhale, they release nutrients, including iron and nitrogen, that fertilize tiny plankton near the surface. These plankton, in turn, form the base of the ocean's food chain and produce much of the world's oxygen. In this way, whales indirectly support all life on Earth, even ours. Scientists call this process the whale pump, and it has enormous effects on the planet's climate and health. When whales die, their massive bodies sink to the seafloor, becoming oases of life for deep-sea creatures. Each carcass can support entire ecosystems for decades. Even in death, whales give back to the ocean that sustained them. Their social lives are equally rich. Some species form lifelong bonds, traveling together in pods and communicating through a mix of sounds, movements, and even physical touch. Mothers are exceptionally protective of their calves, guiding them through migration routes that span thousands of miles. These young whales stay close to their mothers for years, learning vital survival skills. Humpbacks, orcas, and sperm whales all display deep emotional connections, mourning lost companions, celebrating reunions, and cooperating across generations. There is growing evidence that whales possess advanced intelligence and perhaps even culture, a shared knowledge passed through teaching, imitation, and song. Over centuries, whales have inspired awe, art, and myth. Sailors once told tales of sea monsters and leviathans rising from the deep, unaware that these legends were born from encounters with real animals that simply dwarfed their ships. Today, we understand whales not as monsters but as sentient beings, guardians of the deep, symbols of peace and endurance. They have survived ice ages, mass extinctions, and centuries of human hunting. Their resilience speaks of a patience and strength that mirrors the ocean itself. Modern conservation efforts have helped many populations recover, but threats remain, from ship strikes and pollution to climate change and noise that disrupts their communication. Still, whales continue to thrive, migrate, sing, and nurture their young in the silent blue spaces we barely understand. When you listen closely to the ocean, beneath the waves and beyond human hearing, there is an endless song, a living heartbeat that connects the world. It is the echo of the whales. Their voices carry through the depths, ancient and gentle, a lullaby for the planet itself. As you drift towards sleep, imagine those vast creatures gliding through moonlit waters, their breaths rising like mist, their songs rippling across the sea. They remind us that even in a world of noise and haste, there are beings who live in harmony with the rhythm of the earth, guided by instincts older than civilization. When humpback whales hunt together, their strategy unfolds like a choreographed ballet deep beneath the ocean's surface. One whale will dive below a school of fish and begin to swim in an upward spiral, releasing a steady stream of bubbles from its blowhole. These bubbles rise in a circular pattern, forming what scientists call a bubble net, a shimmering, spinning cylinder of air that traps fish inside it like an invisible wall. While this single whale constructs the trap, others take up positions below, producing loud, sudden sounds that scare the fish toward the center of the net and push them closer to the surface. When the moment is right and the fish are crowded tightly together, the whales rise in unison with their enormous mouths open, bursting through the ring of bubbles and swallowing hundreds of fish in a single, coordinated strike. This breathtaking display is not a product of instinct alone but of learned cooperation, timing, and intelligence. Young humpback whales must watch and practice this behavior, learning from their elders how to build and use a bubble net effectively. The entire event lasts only seconds before the bubbles vanish into the sea, but in that brief moment, the whales demonstrate a kind of underwater engineering, crafting and using a net made entirely of air. This cooperation, precision, and social learning reveal a high level of intelligence among whales, showcasing them as some of the most capable strategists in the animal kingdom. Humpback whales are also known for another astonishing behavior, protecting other animals from danger. There have been many recorded cases of humpbacks intervening when killer whales attack their prey. Even when the animal being hunted is not a fellow humpback, sometimes a seal, a gray whale calf, or even a school of fish, humpbacks have been observed rushing in, positioning their massive bodies between the attackers and their victims. They slap their fins, make loud sounds, or create waves to confuse and deter the predators. Scientists are still unsure why they do this. It may be an extension of the strong maternal instinct humpbacks feel for their own calves, an empathetic reaction that sometimes overflows to protect other species. It could also be a form of mobbing behavior meant to teach killer whales that this is not a good hunting ground. Whatever the reason, these rescues are not rare. They happen across the world wherever humpbacks and killer whales overlap. Each encounter reminds researchers that whale intelligence is deeper and more emotionally complex than we once believed, hinting at levels of awareness and empathy that challenge our understanding of non-human consciousness. But whales are not only emotionally intelligent, they are ecological engineers who reshape the very chemistry of the oceans. Each dive and breath contributes to a vast, planetary cycle. When whales feed in the deep, dark waters and return to the surface to breathe or release waste, they bring nutrients from the ocean floor back to the sunlit layers above. Their fecal plumes, clouds of nutrient-rich material, contain nitrogen and iron, two essential elements for the growth of phytoplankton. These microscopic plants form the base of the marine food chain, feeding small fish, krill, and ultimately everything that swims above them. Even more importantly, phytoplankton produce much of Earth's oxygen and play a crucial role in absorbing carbon dioxide from the atmosphere. Before large-scale whaling, the oceans were home to far more whales, meaning this nutrient pump was once much stronger. Scientists now believe that restoring whale populations could actually help combat climate change, as a healthy whale population leads to more phytoplankton, which leads to cleaner air and more carbon storage in the sea. In this way, whales do not merely inhabit the ocean, they sustain it, quietly maintaining balance across the blue planet. Even in death, whales continue to nurture life. When a whale's long journey finally ends, its massive body does not drift endlessly. Instead, it sinks to the ocean floor, where it becomes the foundation for an entire ecosystem. This event is called a whale fall, and it transforms the barren, dark seafloor into a bustling community of life. As the whale's body settles, scavengers such as hagfish, crabs, and deep-sea sharks arrive first, tearing away soft flesh. Over time, smaller creatures move in to feed on the remaining tissue, and finally, specialized bacteria begin breaking down the oils and bones themselves. These bacteria release energy and nutrients that are almost never available in the deep sea, attracting even more life. In fact, over 100 different species can thrive on a single whale carcass, and many of them exist nowhere else on Earth. Some are so specialized that they cannot survive without whale falls. Thus, what seems like the end of one life becomes the birth of an entire miniature world in the eternal darkness. Whales also stand out as some of the longest living creatures on the planet. The bowhead whale, which inhabits the frigid Arctic waters, holds the record for the longest lifespan of any mammal. Some individuals have been known to live for more than 200 years. A bowhead alive today may have been born when steam engines were a new invention or before the American Civil War. Scientists have confirmed these astonishing ages by studying harpoons found embedded in the bodies of whales caught in modern times, harpoons that were manufactured in the 1800s, and by analyzing the chemical changes in the proteins of whale eye lenses, which act like biological clocks. This extraordinary longevity raises fascinating questions. How do whales avoid diseases such as cancer or heart failure for so long? Research suggests that their cells divide more slowly, their metabolism is cooler, and their DNA is exceptionally well protected from damage. These natural defenses may explain their resistance to aging and illness, making whales valuable models for understanding longevity and health in all mammals, including humans. Some bowhead whales still reproduce well into their second century of life. In one remarkable case, a whale estimated to be at least 130 years old was found to be pregnant, a phenomenon almost unheard of among mammals. While humans and many other animals lose fertility with age, whales continue to reproduce, contributing new generations even after more than a century of existence. Scientists believe this may be due to genetic adaptations that preserve the function of reproductive tissues and prevent age-related decline. This long reproductive window helps whale populations recover and maintain stability, which is essential in environments where each calf requires years of care before independence. It also suggests that whales may hold biological secrets capable of teaching us how to extend human health and fertility far beyond our current limits. The memory of whales is just as impressive as their lifespan. Many species return to the same feeding and breeding grounds year after year, following ancient migration routes that have been passed down across generations. There are documented cases of whales reappearing in regions that had been unused for decades, or even a century, after the end of commercial whaling. Scientists believe this indicates either inherited instincts encoded in their DNA or cultural memory passed from mother to calf through teaching. Migration is not random. It is a learned and remembered journey that connects modern whales to their distant ancestors. Some routes stretch across entire ocean basins, linking the icy Arctic with the tropical equator. Despite having no visible landmarks to follow, whales navigate these immense distances with stunning accuracy, possibly guided by ocean currents, temperature gradients, stars, or even Earth's magnetic field. Fossil records show that ancient whales once followed similar paths, visiting the same regions that their descendants still travel today. Even when human interference or climate shifts alter the environment, whales continue to follow their invisible highways through the sea, as though the map of the ocean is etched into their minds. Migration for whales is not simply movement, it is memory, heritage, and identity woven into the rhythm of the planet itself. Perhaps one of the most enchanting aspects of whale life is their music. Humpback whales are famous for their songs, long, haunting sequences of moans, squeaks, and cries that can last for hours and travel across entire ocean basins. But what makes these songs truly fascinating is that they evolve. Each year, the humpbacks of a given region sing a shared melody, but over time, they introduce variations, new notes, new phrases, subtle changes in rhythm. These changes spread across the population, gradually transforming the song until it becomes entirely different from the original version. In some cases, new songs have even spread between distant whale populations thousands of miles apart, much like a popular song traveling through human culture. A tune that began near Australia, for instance, once spread across the South Pacific over several years, adopted by whales in region after region. No other animal changes its vocal behavior so dynamically or so culturally. This suggests that whales not only learn from one another but may appreciate novelty and creativity for their own sake. Their songs are living art, fluid, evolving, and socially transmitted through generations, much like human music. The blue whale, though less musically versatile than the humpback, is no less impressive in anatomy and power. Consider its tongue alone. It can weigh as much as an elephant, over 6,000 pounds, and stretch several feet in length. This enormous organ is not merely for tasting, it acts as a muscular piston that helps the whale feed. When a blue whale opens its mouth to engulf an enormous volume of krill-filled seawater, its tongue pushes forward to force the water out through the baleen plates that line its jaws. These plates act like sieves, trapping the krill inside while the water escapes. Each gulp can contain as much as 90 tons of water, yet within seconds the whale filters out its tiny prey with remarkable efficiency. The process repeats again and again during feeding season, fueling the largest animal that has ever lived, a living reminder of nature's grandeur and balance. Every aspect of a whale's life, from birth to death, from migration to song, speaks of intelligence, patience, and connection. They are creatures of both strength and sensitivity, architects of sound and movement who have shaped the oceans for millions of years. Their existence reminds us that life can be both immense and delicate, ancient and ever-renewing. Beneath the surface of the sea, in a world ruled by darkness and pressure, whales glide through the depths with grace that defies imagination. They carry with them the memory of Earth's history and the promise of its future, living links between the past and the possibilities yet to come. As we learn more about these ocean giants, how they cooperate, protect others, nurture the planet, and even sing, we begin to understand not just the whales themselves, but the deep, interconnected web of life that binds all living things together. And perhaps, As we drift to sleep, imagining them swimming silently beneath the moonlit waves, we can hear the faint echo of their songs, a reminder that the world is larger, older, and more wondrous than we can ever truly know. Whales are among the most fascinating and intelligent creatures on Earth, and their biology, behavior, and culture reveal a world of complexity hidden beneath the ocean's surface. The blue whale, the largest animal to ever live, uses baleen plates, comb-like structures in its mouth, to filter out thousands of tiny crustaceans, such as krill, in each gulp of seawater. Its massive tongue, weighing as much as an elephant, works like a piston, pushing water out and trapping food inside. These tongues are so huge and strong that a human could stand on one without touching the sides of the whale's mouth. The immense power and size of the blue whale's tongue are essential for processing the enormous quantity of food required to sustain its vast body. Even young blue whales must consume hundreds of gallons of milk daily, and their tongues help them guide this nutrient-rich liquid into their growing bodies with precision and force. Communication among whales is equally remarkable. Like humans who speak with regional accents, whales develop unique vocal dialects depending on where they live. Orcas in the North Pacific produce entirely different calls from those in the North Atlantic, and even within the same ocean, pods can have distinct vocal traditions. These differences in sound patterns serve as acoustic signatures that help whales recognize members of their family groups and strengthen their social bonds. Young whales learn these sounds much like human children learn language, through observation, imitation, and practice. These cultural sound patterns can persist for generations, acting as oral histories of whale communities and forming part of the species' collective memory. Scientists now track whale families and migrations through these dialects, discovering how sound plays a central role in shaping identity and connection in the vast underwater world. Whales also carry within their bodies physical testaments to their resilience. In the cold waters near Alaska and Greenland, researchers have discovered bowhead whales with fragments of antique harpoons lodged deep in their flesh, relics from the brutal era of 19th century whaling. Some of these harpoons, made of brass or stone, date back more than 130 years, meaning that the whales not only survived being hunted but also continued to thrive for over a century afterward. This astonishing fact highlights the extraordinary durability of whale tissue and immune systems, which can seal and heal around foreign objects without fatal infection. These whales are living monuments to both the cruelty of human exploitation and the astounding power of survival found in nature's greatest giants. In the frozen Arctic, another mysterious creature captures imagination, the narwhal, often called the unicorn of the sea. Its famous tusk, which can grow more than 9 feet long, is not a horn but a single elongated tooth that spirals out from the left side of its upper jaw. Inside, it contains millions of nerve endings, making it one of the most sensitive biological structures ever discovered. Narwhals use their tusks to sense subtle changes in water temperature, pressure, and salinity, effectively turning this impressive feature into a sensory antenna. Sometimes, males have been seen tapping or stunning fish with their tusks before eating them, suggesting that the tusk may have both practical and social functions, used for hunting, sensing, and perhaps even display, much like a peacock's feathers. Bowhead whales, on the other hand, demonstrate brute strength in the Arctic's icy world. They can break through more than a foot of solid sea ice using the tops of their reinforced skulls, which act like battering rams. Their enormous heads can weigh several tons, and the muscles in their necks are powerful enough to lift this weight to smash upward, creating breathing holes in frozen waters where air is scarce. These whales use their finely tuned hearing to detect thinner areas of ice or existing cracks, showing that survival in such a harsh habitat requires both intelligence and strength. No other whale species can live permanently in such icy waters without the same risk of suffocation, making bowheads the true masters of the Arctic. Orcas, despite being called killer whales, are actually the largest members of the dolphin family. Their intelligence, agility, and strong social bonds make them some of the ocean's most efficient predators. Orcas live in tightly knit pods and hunt cooperatively, using sophisticated strategies that vary depending on their prey. They might corral schools of fish into tight bait bowls, flip seals off ice floes, or even create waves to knock penguins into the water. Around the world, different orca populations have developed unique hunting traditions, diets, and dialects, an incredible example of animal culture. Their physical power matches their mental prowess, with jaws strong enough to tackle even large whales, proving that dolphins can also rule the ocean's food chain. Sleep in whales is unlike that of any other mammal. Because they must consciously surface to breathe, they cannot afford to become fully unconscious. Instead, whales sleep with only half of their brain at a time, a phenomenon known as unihemispheric sleep. While one hemisphere of the brain rests, the other remains alert enough to control breathing, maintain balance, and watch for predators or other dangers. Every few minutes, the active side sends a signal to surface for air, after which the roles switch. This alternating system ensures that whales can rest safely even in open waters. For mother whales, this adaptation is essential, allowing them to stay alert while their calves sleep beside them. This ability shows how evolution fine-tuned the whale brain for both intelligence and survival in a world where total sleep could mean death. Many whales also see the ocean through sound. Toothed whales, like sperm whales, dolphins, and orcas, use echolocation, emitting high-frequency clicks that bounce off objects and return as echoes. From these echoes, whales form detailed mental images of their surroundings, detecting even tiny fish in the dark depths where light never reaches. They can adjust the frequency and intensity of their clicks, much like focusing a flashlight beam, to locate prey or navigate through complex seascapes. This sensory ability is so refined that some scientists believe whales may even detect air pockets inside the bodies of other animals. Echolocation transforms the ocean into a three-dimensional soundscape, giving whales an awareness of their world unmatched by sight alone. Sperm whales, the giants of the deep, have the largest brains of any creature on Earth, weighing more than 20 pounds, 5 times heavier than a human brain. This enormous brain supports not just their echolocation skills but also complex social behaviors, memory, and communication systems that scientists are only beginning to understand. These whales dive thousands of feet in search of squid, holding their breath for over an hour while navigating pitch-black waters using sound alone. The combination of their immense brains, deep diving physiology, and rich social lives suggests that whales experience a world far more sophisticated than we can easily comprehend. Across all these examples, blue whales filtering oceans, bowheads breaking ice, orcas strategizing hunts, narwhals sensing Arctic waters, and sperm whales mapping the deep, the picture of whale life emerges as one of supreme adaptation, intelligence. This massive organ, the whale brain, controls a complex social life, a sophisticated echolocation system, and an enormous body that can dive more than a mile deep beneath the ocean's surface. The brain of a sperm whale, one of the largest in the animal kingdom, is housed within a skull filled with a special oily substance known as spermaceti, which scientists believe helps with sound production, buoyancy control, and focusing echolocation clicks. Sperm whales live in close-knit family groups led by older, experienced females and communicate using distinctive patterns of clicks known as codas. These codas vary from clan to clan, functioning almost like dialects or cultural signatures, illustrating the social and cultural complexity of these creatures. Despite their massive brains, sperm whales do not depend much on vision, as their deep-sea hunting grounds are pitch-black regions where sunlight cannot penetrate. Their intelligence is adapted to a world dominated by sound, pressure, and social bonds, a reality far different from the visual landscape of humans. Among whales, the blue whale reigns supreme as the largest animal to have ever existed on Earth, weighing up to 300,000 pounds, about the same as 30 adult African elephants combined. This incredible mass is possible only in an aquatic environment, where buoyancy counteracts gravity's pull and relieves the strain on bones and muscles. Blue whales sustain their size by consuming tiny shrimp-like creatures called krill, sometimes swallowing several tons in a single day during feeding season. The energy gained from this feeding frenzy is stored as thick layers of blubber, providing insulation against the frigid depths. Their organs, too, are colossal. Their heart alone can pump more than 1,000 gallons of blood with each beat. This massive scale is not constant, however. As whales migrate and their feeding patterns shift, Their body weight can fluctuate by thousands of pounds throughout the year. Whales' existence is a triumph of evolution in a habitat that imposes virtually no limits on size, and they exhibit cultural behaviors that mirror our own. Humpback whales, for instance, create songs that evolve over time, long, structured sequences of sounds that pass from one population to another like cultural memes. These songs follow patterns of verse and chorus, changing subtly each year. When one group of males introduces a new pattern, it may spread throughout entire oceanic populations, even crossing thousands of miles over time as migrating whales share and imitate the tune. This remarkable transmission of song suggests that whales participate in a living cultural tradition, not unlike language evolution in humans. Beluga whales add another fascinating chapter to this story of communication. Known as the canaries of the sea, for their rich vocal repertoire, belugas can mimic a surprising range of sounds, including, in rare cases, human speech. One captive beluga was even recorded producing noises that resembled distant conversation, complete with varying tones and rhythms, confusing divers who thought they heard human voices echoing underwater. Belugas achieve this through unique facial and nasal flexibility, as they produce sounds not with vocal cords but by manipulating air through nasal passages. This remarkable ability to imitate unfamiliar sounds demonstrates a level of auditory learning on par with highly intelligent animals such as parrots and dolphins. Such mimicry may help them communicate across different environments, or adjust their calls in socially complex pods. Despite their intelligence, whales were driven to near extinction by human greed. From the 18th through the early 20th centuries, industrial whaling fleets spread across every ocean, hunting whales for oil, meat, and baleen. Whale oil lit lamps, lubricated machinery, and made soap and candles, while baleen, sometimes called whalebone, was used to stiffen corsets, umbrellas, and even early car parts. Sperm whales were targeted for spermaceti, a waxy oil prized for its clear burning quality. This unrelenting slaughter decimated populations. Blue whales plummeted from hundreds of thousands to fewer than 5,000, and right whales, named because they were the right whales to kill, were nearly wiped out entirely. Only in the 1960s and 1970s did international outrage and scientific advocacy lead to global bans on commercial whaling. Even today, the scars of this exploitation linger, though some whale species have shown astonishing resilience. After being pushed to the edge, populations like the humpback whale have rebounded dramatically, with some growing at more than 10% per year in certain regions. Blue whales off California's coast have returned to near historic numbers, and bowhead whales in the Arctic show encouraging recovery trends. These comebacks are the result of not only the whaling bans but also improved marine protections, cleaner waters, and coordinated conservation efforts through organizations like the International Whaling Commission. Whales remind us that when nature is given time and space, it can heal. Whales also reveal their mammalian heritage through features such as belly buttons, proof that they give birth to live young connected to their mothers by umbilical cords. The resulting scar, long and narrow rather than circular like in humans, gradually fades as the whale matures. This simple feature underscores that whales, despite their oceanic existence, are mammals through and through. They breathe air, nurse their young, and maintain constant body temperatures. Newborn whales, or calves, grow at astonishing rates. A baby blue whale can gain more than 200 pounds a day in its early months, nourished by its mother's incredibly rich milk, which can exceed 50% fat content and has the thick, toothpaste-like texture necessary to prevent it from dissolving in seawater. A calf may drink more than 30 gallons of this dense, creamy milk each day, doubling its weight within weeks. The fat in the milk fuels rapid growth and builds blubber for insulation against the cold. Mothers expend tremendous energy producing such rich nourishment, requiring them to consume vast amounts of krill or fish. This investment ensures that the calf develops strong muscles, bones, and organs before it begins eating solid food. As the calf grows, it learns to swim, breathe, and navigate under the careful guidance of its mother, forming bonds that last for years. Even as adults, traces of their mammalian past remain visible. Whales have hair, though it is sparse and subtle. Newborns are often born with fine whisker-like hairs called vibrissae around the mouth and lips, which help them locate their mothers for nursing. In species like humpbacks, these hairs sometimes persist into adulthood, serving sensory roles connected to touch and movement. These tiny remnants remind us that whales evolved from land-dwelling mammals millions of years ago, shedding most of their fur as they adapted to a streamlined aquatic lifestyle. Still, the nerves beneath these hair follicles remain functional, possibly allowing whales to detect subtle changes in their environment. Among the most fascinating physiological adaptations in whales is their control over heart rate during deep dives. A blue whale's massive heart, which might beat 10 to 30 times per minute at the surface, slows to as few as 2 beats per minute when diving into the deep. This slowdown conserves oxygen, directing blood flow only to vital organs such as the brain and heart, while reducing circulation to the skin and extremities. This slow heartbeat, a critical adaptation known as the diving reflex, allows whales to survive the crushing pressures and oxygen-deprived darkness of the ocean's depths. When a whale dives, its heart rate drops dramatically, sometimes to just a few beats per minute, conserving oxygen and directing blood away from non-essential muscles toward vital organs like the brain and heart. This reflex is far more pronounced in whales than in any land-dwelling mammal, giving them the ability to remain submerged for extraordinary lengths of time while hunting or exploring. As the whale returns to the surface, its heartbeat rapidly accelerates, flooding the body with fresh oxygen and restoring normal function. This precise control over circulation and metabolism is one of the most remarkable survival mechanisms in the natural world. Among the many whale species, the beluga stands out for its physical flexibility and expressiveness. While most whales have stiff necks with fused vertebrae, limiting head movement, belugas are unique. Their separate cervical vertebrae allow them to nod, tilt, and turn their heads freely in almost any direction. This flexibility gives them an impressive range of motion, useful in navigating icy Arctic waters filled with shifting currents, narrow channels, and floating ice sheets. The beluga's rounded forehead, called the melon, serves as an acoustic lens for echolocation and can subtly change shape when the whale vocalizes, giving it a remarkably expressive face. Combined with their head movements and complex vocalizations, these traits make belugas appear unusually human-like in their communication, especially in captivity where they have been known to mimic human voices and respond to gestures. This high level of adaptability makes them one of the most charismatic and socially interactive whale species on Earth. While belugas captivate with their expressions, other whales demonstrate equally fascinating adaptations to survive in the open sea. One such adaptation involves how whales stay hydrated. Despite living their entire lives in saltwater, whales never drink seawater or fresh water directly. Instead, they obtain all necessary water through their food, fish, squid, and tiny crustaceans, and through a biochemical process called metabolic water production, where fat is broken down into energy and water. Their kidneys are specialized marvels of evolution, capable of filtering out excess salt and producing highly concentrated urine, allowing them to remain hydrated in an environment where humans would quickly dehydrate. Even newborn calves rely entirely on their mother's milk for hydration. The milk's high fat content and low salt levels provide both nourishment and water. This intricate balance allows whales to live for decades in the open ocean without ever needing a single sip of fresh water from land. Whales also possess an extraordinary ability to navigate the vastness of the ocean, a skill that has puzzled and fascinated scientists for generations. Many species migrate thousands of miles every year, often returning to the exact same feeding or breeding grounds with astonishing precision. Research suggests that whales use the Earth's magnetic field as a kind of invisible compass. Microscopic magnetic particles called magnetite have been discovered in the brains of some whales and dolphins, indicating that these animals can detect magnetic fields to orient themselves even when the sea looks identical in every direction. This ability would allow whales to navigate across featureless ocean expanses, day or night, cloudy or clear, guided by subtle magnetic cues. Occasionally, disruptions in the Earth's magnetic field, such as solar storms, have been linked to mass whale strandings, suggesting that interference with their internal compass can lead to tragic disorientation. Scientists continue to study this mystery, But it is clear that whales navigate with an exquisite blend of sound, memory, and magnetism, a sensory toolkit unmatched by any human technology. Surprisingly, despite their deep water prowess, whales are also creatures of the sun, and even they can get sunburned. When they surface to breathe, feed, or socialize, their skin, especially the lighter patches, is exposed to ultraviolet radiation. In clear, reflective waters or regions with thinning ozone, UV rays can cause blisters, peeling, and lesions that resemble human sunburn. Blue whales, fin whales, and sperm whales, which often linger near the surface, are particularly susceptible. Over time, whales may develop natural defenses such as increased melanin production, much like tanning in humans, which helps protect their skin. These findings not only reveal another layer of whale biology but also serve as a reminder that even the ocean's largest creatures are not immune to the impacts of changing environmental conditions. Climate shifts, pollution, and variations in sunlight exposure all shape how these animals adapt to an evolving planet. Another defining feature of whales is their remarkable blubber, a thick, fatty layer that serves as insulation, energy storage, and structural support. In some species, blubber can be more than a foot thick, an evolutionary necessity for survival in frigid waters. This layer allows whales to maintain a stable internal temperature even when swimming through icy polar seas where water temperatures dip below freezing. Blubber also streamlines the whale's body, reducing drag as it glides through the water with minimal effort. During migration or fasting, blubber becomes a vital energy reserve, slowly metabolized into fuel and water when food is scarce. It even helps regulate buoyancy and shields internal organs from the extreme pressure of deep dives. Unlike regular fat, blubber is densely packed with blood vessels, forming a complex heat exchange system that allows whales to adjust to rapid changes in temperature between the surface and the depths. This intricate biological engineering exemplifies nature's efficiency, balancing power, endurance, and thermoregulation in one seamless system. Yet perhaps nothing captures the spirit and beauty of whales more vividly than breaching, the breathtaking act of leaping out of the water. Few sights in nature rival the power and grace of a 40-ton humpback whale propelling itself skyward, twisting in midair, and crashing back into the sea with a thunderous splash that echoes for miles. This dramatic behavior, seen across several whale species including orcas, pilot whales, and occasionally even blue whales, serves multiple purposes. Scientists believe breaching may help remove parasites from the skin, serve as a form of communication or social display, or allow whales to get a brief visual survey of their surroundings. During mating seasons, males often breach repeatedly, perhaps to demonstrate strength and vitality to potential mates. Others suggest that breaching helps whales send acoustic signals through the water, the resounding splash carrying information to distant pods. Regardless of the reason, breaching remains one of the most visually stunning and emotionally stirring behaviors in the natural world, a testament to both the physical power and mysterious intelligence of these ocean giants. Together, these adaptations, heart rate control, flexible anatomy, saltwater survival, magnetic navigation, UV resistance, insulating blubber, and acrobatic breaching, paint a portrait of creatures exquisitely designed for life in one of the most challenging environments on Earth. Each trait tells a story of endurance, creativity, and balance. Whales are not simply large animals. They are living blueprints of evolution's finest craftsmanship. They thrive where light fades, where pressure crushes, and where distances defy imagination. Their bodies and behaviors reflect a harmony between biology and environment, a synchronization so precise that it blurs the line between instinct and intelligence. From the beluga's playful gaze to the blue whale's silent strength, every heartbeat, dive, and leap carries a legacy millions of years in the making. They are ancient navigators and guardians of the deep, living reminders of nature's limitless adaptability and quiet wisdom beneath the waves. The astonishing power of whales is evident in their ability to propel their enormous bodies, sometimes weighing tens of thousands of pounds, entirely out of the water in an act known as breaching, a breathtaking display of raw strength and coordination that defies gravity and the imagination alike. Yet beyond their physical prowess, whales also demonstrate remarkable intelligence, social complexity, and even culture. Unlike creatures driven solely by instinct, whales can learn from experience and share their knowledge with others in their pod. One famous example of this intelligence is seen in humpback whales that developed a behavior known as tail feeding, in which they slap their tails against the water's surface before diving beneath to trap schools of fish. Initially observed in only a handful of individuals, this technique quickly spread among neighboring humpbacks, proving that whales are capable of social learning and cultural transmission. Similarly, orcas, or killer whales, have been seen adapting to human presence by learning to steal fish from commercial longlines after observing a few bold individuals do it first. These observations reveal a capacity for imitation, problem-solving, and innovation that rivals even some primates. Within whale societies, particularly among orcas, these learned behaviors can develop into rich cultural traditions that are passed down across generations. Orca pods, tight-knit family groups, are each known to possess distinct dialects, hunting methods, and social customs, akin to the unique cultures of human communities. These traditions are learned, not inherited through genetics, meaning young orcas spend years watching, practicing, and perfecting the skills their elders teach. For example, orcas in the Pacific Northwest focus their efforts on catching salmon, while others hunt seals or dolphins, sometimes employing entirely different strategies. Along the Argentine coast, a particular group of orcas has mastered the daring art of intentional beaching, sliding onto the shore to snatch unsuspecting seals before wriggling back into the waves. Mothers teach this technique to their calves through patient repetition, ensuring it remains part of the pod's cultural memory. The calls and whistles each pod uses also form a unique dialect that distinguishes one group from another, enabling them to recognize relatives even across vast distances. This level of communication and learned tradition is nearly unparalleled among non-human predators, marking orcas as a species with one of the most complex social systems in the natural world. Their intelligence also shines in their hunting. Orcas adapt their tactics based on prey type and environment, working together in ways that demonstrate coordination and foresight. When hunting large whales, they form highly synchronized teams to distract and isolate calves from their mothers. In other contexts, they herd fish into tight balls and take turns rushing in to feed, or generate waves to knock seals off ice floes, a strategy seen only in specific pods that have learned and refined the behavior over time. In warmer waters, certain groups even employ a method called carousel feeding, where they flash their white bellies to confuse fish, exploiting light and motion as tools of deception. Such strategic diversity underscores their adaptability and intelligence, allowing orcas to thrive in every ocean on Earth. This extraordinary ability to think, plan, and teach reveals not just instinct but awareness and cooperation, qualities that mirror our own evolutionary intelligence. Long before these giants became masters of the sea, however, their ancestors walked on land. Fossil evidence tells the remarkable story of whale evolution, tracing their lineage back over 50 million years to four-legged mammals that lived in lush coastal environments. Early species such as Pakicetus and Ambulocetus, whose names mean whale of Pakistan and walking whale, respectively, were semi-aquatic creatures resembling a blend of wolf and crocodile, equipped with long snouts, sharp teeth, and strong limbs for wading through shallow waters. Over countless generations, some of these creatures began spending more time hunting in the water, where prey was plentiful and competition fewer. Natural selection favored traits that made aquatic life easier. Legs evolved into powerful flippers, nostrils migrated upward to become blowholes, and tails developed broad horizontal flukes for propulsion. Over millions of years, these transitional forms gave rise to fully aquatic whales. Intriguingly, modern whale skeletons still contain small remnants of hind limb bones buried deep within their flesh, ghostly reminders of their terrestrial past. This evolutionary journey from land to sea is among the most dramatic transformations in Earth's history, illustrating the incredible adaptability of life when confronted with new environments. Even more fascinating is how whales preserve records of their individual lives within their own bodies. Deep inside their ear canals lies a waxy plug, a massive accumulation of earwax that forms in distinct layers over time. Like tree rings, These alternating light and dark bands can be counted to determine a whale's age. Yet these layers also capture chemical traces from the bloodstream, serving as a biological archive of the whale's experiences. By studying these earwax plugs, scientists can uncover information about a whale's diet, hormone levels, and even exposure to pollutants throughout its lifetime. Spikes in stress hormones reveal when the whale underwent migrations, breeding cycles, or periods of starvation, while traces of pesticides and industrial chemicals tell stories of environmental contamination from decades past. This natural record-keeping system offers a rare and detailed insight into the hidden lives of these marine giants. Among the most formidable of all whales is the sperm whale, a deep-sea hunter whose battles with the mysterious giant squid are the stuff of legend. Sperm whales routinely dive over a mile beneath the surface into the pitch-black abyss where sunlight cannot reach. Using powerful echolocation clicks, some of the loudest biological sounds on Earth, they navigate the darkness, scanning for prey. When a giant squid is detected, the whale closes in, guided by sound rather than sight. The ensuing struggle is silent but intense, with the squid lashing out its tentacles in defense, leaving behind circular suction marks on the whale's face and skin. These scars, seen on countless sperm whales, stand as evidence of these titanic encounters that take place far below human reach. A single deep dive may last over an hour before the whale resurfaces to breathe, only to descend again moments later. Despite the risks and the immense energy costs, sperm whales rely heavily on squid for sustenance, consuming hundreds of pounds each day. Their hunts remind us that much of the ocean remains unexplored and that the deep sea hides wonders we still barely comprehend. Equally impressive are gray whales, whose annual migration ranks among the longest of any mammal on Earth. Every year, these resilient travelers journey more than 10,000 miles round-trip, moving from their feeding grounds in the Arctic, where they gorge on swarms of tiny crustaceans, to the warm lagoons of Baja California, Mexico, where they give birth and raise their calves. This marathon voyage demands not only extraordinary physical endurance but also an astonishing sense of direction and memory, as the whales navigate vast stretches of open ocean with unerring accuracy. Gray whales undertake one of nature's most remarkable migrations, traveling thousands of miles each year through shallow waters along the continental shelf, guided by an intricate combination of coastline landmarks, ocean currents, and possibly even Earth's magnetic field. This epic journey, stretching from the icy Arctic feeding grounds to the warm, sheltered lagoons of Mexico, is fraught with challenges: shipping lanes bustling with vessels, predators lurking beneath the waves, unpredictable storms, and vast stretches of ocean with little food to sustain them. Pregnant females make this migration while carrying calves, ensuring that their young are born in safe, temperate waters where they can be nursed without the immediate threat of orcas or harsh cold. After giving birth, these resilient mothers must once again swim thousands of miles north, nurturing their calves along the way and teaching them the migratory routes that will guide them throughout their lives. This extraordinary cycle of endurance, memory, and instinct serves not only to ensure the survival of each individual whale, but also to maintain the continuity of their species' ancient migratory traditions. Yet, this magnificent voyage also makes them vulnerable. Changes in climate, rising ocean temperatures, increased ship traffic, and pollution threaten their routes and feeding grounds, disrupting a delicate rhythm that has persisted for millennia. Among the giants of the ocean, few are as awe-inspiring as the blue whale, the largest animal ever to have lived on Earth, and one of the loudest. The blue whale's call can reach an astonishing 200 decibels, louder than a jet engine at takeoff, though its deep, low-frequency tones are far below the range of human hearing. These infrasonic sounds travel vast distances through the ocean's deep sound channels, unique layers of water where temperature and pressure allow sound waves to carry for hundreds or even thousands of miles with minimal loss of energy. Through these channels, blue whales can communicate across entire ocean basins, their voices echoing through the dark, unseen corridors of the deep. During mating seasons, they produce long, rhythmic pulses, slow, haunting songs that can last for hours, resonating like the beating heart of the sea itself. Scientists believe these calls help whales find one another across immense distances, coordinate movements, and maintains social bonds. Despite decades of research, much about their vocal language remains a mystery. What exactly do these sounds mean? Are they expressions of emotion, navigation cues, or coded messages that span generations? Whatever their purpose, these songs form one of the most mesmerizing and mysterious soundscapes in the animal kingdom, a living symphony beneath the waves. Whales also play an essential, if often overlooked, role in maintaining the health of the planet's oceans and atmosphere through a process known as the whale pump. When whales feed at great depths and return to the surface to breathe, they release waste rich in nitrogen and iron, two nutrients vital for the growth of microscopic phytoplankton. These tiny organisms form the foundation of the marine food web and are responsible for producing over half of Earth's oxygen. In essence, every time a whale defecates near the surface, it acts as a natural fertilizer, sparking a bloom of life that sustains fish, krill, and other sea creatures while simultaneously capturing vast amounts of carbon dioxide from the atmosphere. In regions where whale populations were historically abundant, the ocean itself was more productive, teeming with life. Modern research suggests that restoring whale populations could help rebalance marine ecosystems and even slow climate change by enhancing the ocean's carbon absorption capacity. Thus, each whale is not merely a creature of the sea but a vital engineer of the global environment, a guardian of balance between the sky and the deep. Even a whale's breath tells stories of its secret life. When a whale exhales, the burst of vaporized air, known as a blow, can sometimes change the color of the surrounding water. This exhalation is more than just water vapor. It contains oils, salts, and microscopic particles that reveal traces of the whale's recent meals and environment. Humpback whales, for example, often release yellowish clouds due to digested krill and plankton, while fin whales may emit greenish or reddish hues depending on the type of prey they have consumed. These color variations are fleeting, vanishing in seconds, yet they offer scientists valuable clues about the whale's diet, health, and migratory routes. Researchers can even collect droplets from the mist of a blow to study hormones, bacteria, or chemical compounds, gaining insights into the animal's physiology without disturbing it. Every exhale, therefore, becomes a fingerprint of ocean life, a brief but telling mark of the unseen world that thrives beneath the waves. Whale eyes, too, are marvels of evolution, designed to function in two vastly different environments: the dazzling brightness of the sunlit surface and the pitch-black depths of the abyss. At the surface, whales must navigate glaring reflections and refracted light bouncing off waves. At depth, they rely on faint glimmers of bioluminescence and the barest hints of contrast. To handle this duality, whale eyes have evolved large spherical lenses that gather and focus light efficiently, as well as highly sensitive rod cells in their retinas that excel in dim illumination. Their pupils can dilate widely to capture what little light exists in the deep, and their eyes are protected by oily secretions that act like natural goggles, preventing dehydration from salt water. Although their vision is not as sharp or color-detailed as human sight, whales perceive movement and contrast exceptionally well, skills crucial for detecting prey, predators, and other whales in dark or murky water. Some species may even see ultraviolet light, granting them an extrasensory edge in low-visibility environments. These adaptations make their eyes both resilient and perceptive, attuned to a world that alternates between blinding light and eternal night. Among whales, orcas, also known as killer whales, stand out not only for their intelligence and adaptability but also for their diverse cultures and languages. Orcas across the globe communicate using dialects unique to their pods or families. Each pod has its own distinctive pattern of clicks, whistles, and pulsed calls, functioning almost like an accent or tribal language. These dialects allow orcas to recognize one another and maintain strong social bonds, even distinguishing members of different clans. In some regions, neighboring pods have entirely different vocal repertoires despite overlapping territories, reflecting a complex system of learned communication passed down through generations. These vocal differences also correlate with variations in behavior and diet. Some orcas specialize in hunting fish, while others target seals, dolphins, or even large whales, using intricate teamwork and specialized hunting methods that reflect their local traditions. This capacity for learning, memory, and communication reveals an astonishing depth of culture in a non-human species. Each pod's identity is shaped by its calls, its hunting style, and the social ties that bind it, proof that in the silent expanse of the ocean, voices still matter deeply. Taken together, all these traits, the gray whale's epic migration. Orcas, also known as killer whales, are among the most intelligent and socially complex creatures in the ocean, using an intricate system of clicks, whistles, and pulsed calls to communicate with one another. Each pod of orcas has its own dialect made up of unique vocal patterns that are learned socially rather than genetically, passed down from mothers to calves like cultural traditions. These dialects are so distinctive that scientists can identify specific groups and track their family trees based on sound alone, almost like recognizing a human community by its language. For example, orcas in the Pacific Northwest have vocal traditions entirely different from those in Antarctic waters, with each group's repertoire shaped by its history and environment. When two pods meet, they can recognize one another's calls instantly, but if their dialects differ too much, they rarely mix or interbreed, suggesting that vocal identity defines social and family boundaries. This separation by sound reveals that for orcas, communication is more than a biological function, it's a form of culture. The diversity of these dialects offers one of the rarest insights into non-human societies, showing that some animals, like humans, live within systems of shared knowledge and inherited sound traditions. Whales as a group display remarkable adaptations not only in their communication but also in their behaviors, including the way they rest. Unlike humans, whales never fully shut down their bodies during sleep because they must continue to surface to breathe, remain aware of predators, and stay oriented in the vast ocean. To solve this challenge, many species, including orcas, dolphins, and sperm whales, have developed a fascinating adaptation called unihemispheric slow-wave sleep, where only one half of their brain sleeps at a time while the other half stays awake enough to control breathing and gentle movement. This unique form of rest allows whales to drift or swim slowly in circles near the surface, maintaining a balance between vigilance and recovery. Some species, such as pilot whales, have been observed forming tight, synchronized groups during rest, their bodies aligned vertically in the water, as if sharing a collective dream. Their eyes may close, but their movement continues, a rhythmic slow dance between consciousness and sleep. Because half their brain remains alert, scientists are unsure whether whales truly dream in the human sense. In people, vivid dreams occur during rapid eye movement, REM sleep, a phase marked by intense brain activity and temporary paralysis. Whales do not seem to enter long REM cycles, yet some researchers believe that while they rest, they may still process experiences or replay sounds, learning vocalizations or refining navigational skills. This could explain how calves learn migration routes and social behaviors during their early development, resting safely beside their mothers while absorbing the rhythms and patterns of the pod. Though we cannot measure their brainwaves in the open ocean, the possibility remains that whales dream in ways beyond our comprehension, perhaps in waves of sensation or fragments of memory carried through the deep blue silence. The physical form of whales also tells a profound evolutionary story. Inside the sleek flippers of these massive marine mammals lies a structure astonishingly similar to that of a human hand. Beneath layers of muscle and blubber are wrist bones, palm bones, and finger bones, remnants of their land-dwelling ancestors that once walked on four limbs millions of years ago. Over countless generations, evolution reshaped these limbs into perfect tools for aquatic life, broad, strong paddles that provide stability and steering power. The arrangement of these bones gives whales precise control over their movements, allowing them to execute graceful turns, balance their massive bodies during feeding dives, and glide effortlessly through the water with minimal energy. In humpback whales, this adaptation reaches its most remarkable form. Their elongated flippers are lined with distinctive knobs, or tubercles, along the leading edge. These structures help channel water smoothly over the surface, reducing drag and increasing lift much like the wings of an airplane. This evolutionary innovation allows humpbacks to perform complex acrobatics, breaching entirely out of the water or twisting midair with astonishing agility despite their immense size. The study of whale flippers provides an extraordinary example of how life transforms to fit new worlds. From ancient creatures that once roamed on land, whales became masters of the sea, carrying within their skeletons a silent record of their terrestrial past. Together, these aspects of whale biology, communication, rest, and anatomy, reveal a portrait of animals whose lives blend intellect, adaptation, and beauty. Orcas' inherited languages show that culture is not uniquely human. Whales' sleep illustrates the creativity of evolution in sustaining life in impossible conditions. And their bones, shaped by time and ocean currents, remind us of the shared ancestry that links all living things. Each whale, in its vast ocean home, carries the story of Earth's changing history, singing it across waters where generations listen, learn, and dream in the deep. The hidden resemblance between whale flippers and human hands offers one of the most striking examples of evolution's creativity and continuity, showing that nature tends to reshape existing structures rather than invent new ones from scratch. Beneath the smooth, paddle-like surface of a whale's flipper lies a familiar framework: wrist bones, palm bones, and finger bones arranged in the same order as our own. This shared anatomy reveals that whales descended from land-dwelling ancestors that once walked the earth, their limbs gradually transforming over millions of years into powerful tools for steering through the sea. Instead of erasing the past, evolution rewrote it, adapting ancient bones for a new world. But whales are not only biological marvels, they are also emotional and social beings whose behaviors often mirror human expressions of love, cooperation, and even grief. Scientists have recorded numerous instances of whales mourning their dead in ways that seem heartbreakingly familiar. Across species, from orcas and belugas to pilot and sperm whales, mothers have been observed carrying the bodies of their dead calves for days or even weeks, gently lifting them toward the surface as though unwilling to let go. Other whales have been seen circling or nudging deceased pod members, producing sorrowful vocalizations that suggest attempts at comfort or communication. These gestures, though we cannot fully interpret them, convey an unmistakable sense of attachment and loss. While it remains scientifically uncertain whether whales experience grief as humans do, their actions indicate a deep emotional intelligence and awareness of death. Many researchers believe that such mourning behavior strengthens social bonds, allowing individuals within a pod to process loss together and maintain group cohesion. The fact that whales engage in this behavior across vast oceans points to an internal emotional life far more complex than once imagined, one that includes love, sorrow, and remembrance. This emotional richness extends beyond mourning into the realm of music and communication, where whales display extraordinary sophistication. While the haunting solo songs of humpback whales are well known, scientists have discovered that some species also perform duets, joining their voices in synchronized patterns of sound. In these rare instances, two whales match their pitch, rhythm, and phrasing so precisely that their calls intertwine like a single, seamless composition. These duets may serve multiple purposes: courtship, coordination, or territory defense, but they all reflect an astonishing degree of cooperation and auditory awareness. In some cases, the whales alternate parts, responding to one another in call and response exchanges that resemble a musical dialogue, almost like jazz musicians improvising across the waves. This duet behavior proves that whale songs are not merely instinctive noises. They are learned, shared, and adapted over time, reflecting both individual creativity and social learning. Much like human music, whale song carries emotion, memory, and culture, revealing how profoundly sound can connect living beings across space and time. Among all whales, the male humpback stands out as one of nature's most dedicated performers. Only males produce the long, intricate songs that have fascinated scientists for decades. Compositions that can last up to 30 minutes and are built from repeating phrases arranged into themes that evolve gradually over time. These haunting melodies echo through the ocean, sometimes repeated for hours as the singer hovers motionless in the deep, head angled downward, his body a living instrument tuned to the rhythms of the sea. The exact purpose of this singing remains a mystery. Most evidence suggests it is linked to mating, an elaborate courtship display or a form of competition between males. But curiously, no one has ever observed a female visibly responding to a song. What researchers do know is that these songs change each season, spreading like cultural trends through populations as groups learn and modify new variations. Sometimes entire regions adopt a new version of the song, passing it across thousands of miles as if through a musical migration. This phenomenon, an evolving, shared composition passed socially from one population to another, is almost unheard of outside humans and a few bird species. It suggests that whales possess not only intelligence but also a form of artistic culture, capable of learning, memory, and creative expression that rivals our own. Their ability to modify shared sound structures is a sign of collective intelligence, a cultural inheritance passed down through generations of singers beneath the waves. Just as their songs carry memory, whales themselves possess extraordinary memories that extend across years and even decades. There have been multiple recorded cases of whales recognizing and reacting differently to specific humans after long absences, showing a remarkable ability for individual recognition and emotional recall. In areas where whales interact frequently with people, such as in regions of research or rescue, scientists have observed that whales respond more calmly and positively to familiar humans who treated them gently, while showing caution or avoidance towards strangers. Captive studies with orcas and belugas have confirmed that whales can distinguish humans by sight, voice, and even posture, recognizing nuances of behavior and personality. Some gray whales off the coast of Mexico appear to seek out specific boat operators they remember, approaching their vessels and allowing those individuals to touch or interact with them, while ignoring other boats nearby. This selective memory suggests a mental map that includes not only environmental features and migration routes, but also social relationships, with both their own kind and ours. Such selective social memory, extending beyond immediate survival needs, implies a level of emotional intelligence and consciousness once thought unique to humans. Together, these observations reveal whales as beings of profound depth, creatures whose bodies hold the story of evolution, whose hearts show empathy and grief, whose voices weave music across oceans, and whose minds remember individuals with care and intention. From the skeletal echo of a human hand in a flipper to the haunting harmony of a humpback's song, whales remind us that intelligence, emotion, and creativity are not confined to land or to our species. They flow through the living ocean, expressed in the language of touch, sound, and memory. Each whale's life is a moving symphony of biology and feeling, an ancient story of adaptation written in bone, sung in water, and remembered across generations in the timeless rhythm of the sea. When humpback whale calves are born, they emerge into an ocean that is both vast and full of danger, yet from their very first moments, they display instincts shaped by millions of years of evolution. Baby humpbacks stay close to their mothers for protection, warmth, and guidance, shadowing them constantly through the gentle rise and fall of the waves. But scientists have discovered a remarkable behavior that sets these young whales apart from most other marine animals. They whisper. Instead of producing the loud, resonant calls that adult whales use to communicate across miles of open water, calves emit soft grunts, faint squeaks, and murmurs so quiet they barely travel more than a few meters. This, whispering, is believed to be a survival mechanism, a way for mothers and calves to communicate without alerting predators such as orcas and large sharks, which can detect sound from great distances. Using underwater microphones placed near migrating mother-calf pairs, researchers identified these faint, secretive exchanges and found that they differ acoustically from adult whale songs, almost as if mother and child are speaking in a private language. This hushed communication prevents not only predators but also other whales from detecting the calf, reducing interference during this vulnerable stage of life. Whispering, in this context, is not merely soft sound, it is deliberate, intelligent adaptation, a quiet act of survival that shows even the youngest whales possess an instinct for strategy and stealth in a world where silence can mean safety. As these young whales grow, they inherit an ancient legacy of movement across the world's oceans, for whales are great travelers, navigators of the sea who follow invisible routes linking the poles to the tropics. Among all mammals, the gray whale holds the record for the longest known migration, completing a round-trip journey of more than 10,000 miles each year between feeding grounds in the icy Arctic and breeding lagoons in the warm waters of Mexico. Humpback whales too make vast migrations, traveling thousands of miles between polar feeding zones and tropical breeding areas, often retracing the same paths year after year with astonishing precision. Blue whales, the largest creatures ever to live on Earth, have been tracked moving from cold, krill-rich waters of the Southern Ocean to the warmer equatorial seas to breed. These epic migrations require immense endurance, timing, and navigational skill. Whales must know exactly when to depart so that food will be plentiful when they arrive at feeding sites and conditions warm and calm enough for giving birth in breeding areas. The journey may take weeks or even months, often without feeding, forcing them to rely on thick layers of stored fat for energy. Some scientists believe whales navigate using a combination of the Earth's magnetic field, ocean currents, and memory passed through generations. These migrations, stretching across entire ocean basins, link distant ecosystems and help distribute nutrients and energy throughout the seas, showing how deeply whales influence the rhythm and structure of marine life. Yet beyond their physical endurance, whales are also social and emotional beings whose relationships rival those of any other intelligent species on Earth. Many whales form long-lasting friendships and complex social bonds that can persist for years or even decades. In dolphin-like species such as orcas and pilot whales, individuals travel with the same companions throughout most of their lives, forming pods that function like extended families. These groups are not based solely on kinship but also on compatibility, shared behaviors, and mutual trust. In humpback whales, researchers have observed pairs meeting again and again across different years and migration routes, greeting one another with apparent recognition and preference. Female sperm whales live in tightly knit matriarchal families that raise calves together, defend against predators, and even adopt orphaned young, ensuring that no calf is left without care. These enduring social networks allow whales to communicate, cooperate, and pass on knowledge vital to survival. Friendship among whales is not accidental, it is actively nurtured through touch, synchronized swimming, and shared vocalizations. They rub against each other affectionately, swim in coordinated patterns, and exchange calls that seem to reinforce emotional connection. Some whales even engage in play, tossing seaweed, breaching joyfully, or swimming belly to belly in apparent companionship. These interactions reveal emotional depth, joy, empathy, and even mourning that parallels many aspects of human social life. Perhaps the most astonishing part of a whale's life begins even before birth. Unlike most land mammals that are born head first, many whale calves enter the world tail first, an evolutionary adaptation that prevents drowning during delivery. If the baby's head were to emerge first, it could accidentally inhale water before reaching the surface. By being born tail first, the calf's blowhole, the nostril located on top of its head, remains safely underwater until the very last moment. As soon as the calf's body is fully delivered, the mother gently nudges it upward with her nose or fins, guiding it toward the surface for its very first breath of air, a vital moment that must occur within minutes to avoid suffocation. The newborn's first exhalation often creates a small, misty spout, marking its entrance into the living ocean. Being born tail first also reduces the risk of the baby becoming trapped in the birth canal, since the narrow tail can pass through more easily and prevent blockage. This adaptation highlights how perfectly whales have evolved for marine life, balancing the delicate requirements of breathing air while living entirely in water. From the first whispered sounds between mother and calf to the grand migrations that unite the world's seas, the life of a whale is a masterpiece of endurance, intelligence, and emotional richness. Each aspect of their existence, from the silent communication of newborns to the lifelong friendships of adults, reveals a species deeply attuned to its environment and to one another. Their migrations connect ecosystems thousands of miles apart. Their births embody precise evolutionary design. Their relationships mirror empathy and loyalty found in human societies. The ocean, though immense and often perilous, is home to these giants who move with grace and purpose, carrying within their memories the ancient rhythms of the planet. In their quiet whispers, their synchronized songs, their migrations through dark and light, whales tell a story not just of survival, but of profound connection, to each other, to their young, and to the living pulse of the sea itself. Whale calves enter the world in a setting where every second, every movement, and every breath is a matter of survival, and their remarkable tail-first birth method exemplifies the extraordinary alignment between anatomy and environment that evolution has crafted over millions of years. Being born tail first allows the calf precious seconds to orient itself, ensuring that its blowhole, the vital air passage, is the last part of the body to emerge, thus reducing the risk of inhaling water and increasing the likelihood of survival in a three-dimensional aquatic environment where gravity, pressure, and the immediate need for breath all converge. Once born, the calf must take its first breath at the surface within minutes to avoid suffocation, guided gently by the mother's body and nudge of her fins, marking the start of a life in a world where efficiency and adaptation are everything. The respiratory system of whales is among the most efficient on the planet, capable of exchanging up to 90% of the air in their lungs with each breath, a stark contrast to humans who typically renew only a fraction of lung air per inhalation. This incredible efficiency, combined with the high levels of hemoglobin and myoglobin in their blood, allows whales to store and transport oxygen efficiently, sustaining them through dives that can last for more than 2 hours in some species. Their lungs are highly collapsible under pressure, preventing the formation of air bubbles and blood vessels and avoiding decompression sickness, while a single pulse of air at the surface can replenish the majority of their oxygen reserves, minimizing exposure to predators and enabling them to spend long periods in the deep ocean hunting, navigating, or migrating. Temperature regulation in whales is another marvel of evolution. Warm-blooded animals swimming in cold oceans generate significant heat through muscular activity, feeding, and continuous motion, yet maintaining an optimal internal temperature is critical. Whales manage this through a sophisticated system of countercurrent blood vessels concentrated in their flippers, dorsal fins, and tail flukes, where warm blood from the body core transfers heat to cooler blood returning from extremities. By adjusting blood flow through these regions, whales can release excess heat into surrounding water without expending energy or surfacing, effectively using their flippers as natural radiators despite the insulating presence of blubber elsewhere. This adaptation allows whales to transition between freezing deep waters and warmer surface areas while migrating across seasons, maintaining thermal stability during long periods of rest or exertion. Orcas, or killer whales, epitomize adaptability, inhabiting every ocean from icy polar regions to tropical seas. Their ability to survive in such varied climates stems from a combination of diet flexibility, advanced social behaviors, and remarkable physiological adaptations for thermoregulation. In Arctic waters, orcas patrol ice edges hunting seals, narwhals, and penguins, while tropical populations target rays, fish, or even other whales. Their contrasting black and white coloration aids camouflage, blending with bright surface waters from below and dark depths from above, allowing them to thrive across environments. Cultural behaviors within distinct orca populations, passed down through generations, further enhance survival, enabling the same species to hunt vastly different prey without evolving into separate species. Movement and speed in whales also reflect extraordinary specialization. Certain species are capable of remarkable bursts of velocity that rival some of the fastest marine predators. Orcas and pilot whales can reach speeds exceeding 30 miles per hour during hunts or escapes, while even the enormous fin whale, second only to the blue whale in size, can reach over 20 miles per hour. These feats are powered by immense tail muscles and streamlined bodies that minimize drag, with whales propelling themselves by moving their tails up and down rather than side to side like fish, generating powerful thrusts that enable rapid acceleration and long-distance travel. Such speed is essential not only for chasing prey but also for evading potential threats and efficiently covering vast distances during migrations. Whales exemplify a level of coordination and efficiency in their movements that reflects millions of years of evolution. Every aspect of their anatomy, from collapsible lungs to high-capacity blood oxygen storage, from countercurrent heat exchange in extremities to the vertical propulsion of their powerful tails, is integrated into a system designed for survival in an environment that demands both endurance and precision. These adaptations, combined with behavioral strategies such as maternal guidance of newborns, strategic breathing at the surface, and cultural learning passed through pods, demonstrate how whales have mastered life in the ocean across scales of time, distance, and complexity. They are not merely inhabitants of the seas. They are architects of ecological and social systems, shaping their environments and adapting seamlessly to both the physical and social challenges of marine life. From birth to adulthood, every action in a whale's life reflects a synthesis of anatomical design, behavioral intelligence, and environmental mastery, allowing them to thrive in waters ranging from the tropical equator to the icy Arctic, in short bursts of speed or prolonged periods of deep diving, navigating vast migrations with unmatched endurance, and maintaining social bonds that echo the deepest levels of cooperation, memory, and emotional connection found in the animal kingdom. Each tail beat, each exhale, and each strategic dive is a testament to a lineage that has evolved for absolute efficiency, a lineage that shows how a species can harmonize body, mind, and environment into one coherent system of survival, power, and grace, moving through the ocean as both predator and navigator, teacher and learner, guardian and explorer, perfectly adapted to a world that demands nothing less than excellence in every breath, every movement, and every choice. Whales are extraordinary examples of evolutionary engineering, their bodies and behaviors refined over millions of years to master the vast and demanding environment of the oceans. From the moment they are born, whales are equipped to survive and thrive in a world where precision and efficiency are critical, with newborn calves learning to swim within weeks to keep up with their mothers during migrations that can span thousands of miles. Their ability to cover entire ocean regions in days demonstrates not just immense physical power, but also an inherent aptitude for movement, coordination, and endurance that is built into their anatomy from birth. Underneath this natural athleticism lies an even more remarkable physiological adaptation. Whales possess a built-in dive computer in their blood chemistry, enabling them to perform deep and prolonged dives that no land animal could hope to match. Their blood is loaded with oxygen, stored not only in the lungs but within the muscles and vascular system, and specialized proteins like myoglobin allow oxygen to be retained in muscle fibers for use during extended periods without breathing. Their cardiovascular system constricts blood flow to non-essential areas like the skin and extremities while maintaining oxygen supply to critical organs such as the heart and brain, and their heart rate can drop dramatically during a dive, reducing oxygen consumption and conserving energy. These internal processes operate instinctively, like a finely tuned automatic dive computer, allowing whales to descend thousands of feet into crushing pressures and return safely to the surface, a capability that is a testament to the perfection of millions of years of evolution. Whales are not only adapted for movement but also for survival in extreme thermal conditions. They are warm-blooded mammals swimming in cold oceans, generating heat through muscle activity and constant movement, yet they must maintain an optimal core temperature. To do so, they employ a sophisticated system of countercurrent blood vessels concentrated in their flippers, dorsal fins, and tail flukes, allowing warm blood from the body's core to transfer heat to cooler returning blood. By modulating blood flow through these regions, whales can release excess heat into the surrounding water without energy expenditure, effectively using their extremities as natural radiators. This adaptation allows them to move between freezing depths and warmer surface waters, maintaining thermal balance during long migrations or periods of rest. Killer whales, or orcas, demonstrate remarkable adaptability, inhabiting oceans ranging from icy polar regions to tropical seas. Their survival across such diverse climates is supported not only by physiological flexibility but also by a highly adaptable diet and sophisticated social structures. In the Arctic, orcas hunt seals, penguins, and narwhals, whereas tropical populations target rays, fish, or even other whales, and their contrasting black and white coloration aids in camouflage by blending with bright surface waters from below and dark ocean depths from above. Cultural behaviors passed down through pods allow orcas to thrive in particular environments without needing to evolve into separate species, highlighting the interplay of biology and social learning in their survival. Speed and movement are equally impressive. Certain whale species are capable of explosive bursts of velocity, rivaling some of the fastest marine predators. Orcas and pilot whales can reach speeds exceeding 30 miles per hour, while the enormous fin whale can surpass 20 miles per hour. These bursts of speed are powered by massive tail muscles and streamlined bodies, with propulsion generated by up and down tail movements, rather than side to side like fish, maximizing thrust and efficiency. Such speed is essential for catching fast-moving prey, evading predators, and traversing long distances during migration. Combined with their respiratory and cardiovascular adaptations, whales are capable of maintaining endurance and rapid bursts of activity in ways that few other species can match. The evolutionary story of whales also intersects with human history. Baleen, the flexible keratinous material used by some whales to filter tiny prey like krill from seawater, was once highly prized by humans. It was lightweight, resilient, and springy, and before the advent of synthetic materials, it was used to make corsets, hoop skirts, collars, umbrella ribs, carriage frames, and even bristles for whips and brushes. During the 19th century, commercial whaling led to a global demand for baleen, with factories lining waterfronts to process it for fashion and industry. Today, baleen serves as a reminder of a time when human innovation exploited whale anatomy, a period in which the life of these ocean giants was weighed against the needs of style and invention. Despite this history, whales continue to evolve. Modern populations are adapting to changing oceans, fluctuating food availability, climate change, and human activity. Genetic studies reveal ongoing selection in genes related to immunity, metabolism, and sensory development. Killer whales, for example, are evolving to specialize in new food sources as fish populations decline, and fin whales show changes in hearing sensitivity, likely in response to noisy oceans filled with ships and sonar. Even body size adapts. In regions with scarce resources, calves are born smaller, better suited for survival during long migrations. Evolution in whales is often subtle, a shift in behavior, physiology, or anatomy that enhances survival and is passed to the next generation, demonstrating that whales remain on a continuous evolutionary journey, influenced not only by natural forces but also by the human impact on their environment. Whale communication is another area of remarkable sophistication. Many whales, particularly blue and fin whales, communicate in infrasonic frequencies that humans cannot hear without specialized equipment, with some vocalizations falling below 10 Hz. These low-frequency sounds can travel for hundreds of miles through dense seawater, potentially connecting individuals across entire ocean basins. The complexity of whale song extends to the structure and social function of communication. Humpback whales, for instance, produce long, intricate songs, and some species engage in duets where two individuals synchronize their calls in patterns that resemble musical conversations, potentially serving purposes such as courtship, territory establishment, and social coordination. Male humpbacks are primarily responsible for these elaborate vocalizations, which can last up to 30 minutes and consist of repeating phrases arranged into evolving themes that change seasonally, spreading across populations and ocean regions like cultural waves. Even newborn humpback calves display sophisticated acoustic behavior by whispering to their mothers with soft grunts and squeaks designed to stay undetected by predators, demonstrating that whales are born with instincts for stealth, strategy, and survival in a vast ocean filled with potential threats. Social bonds among whales are profound and enduring. Many species form long-lasting friendships and complex familial networks that extend across years or even decades. Orcas and pilot whales often maintain lifelong associations within pods based on kinship, compatible personalities, and mutual protection. Female sperm whales raise calves collectively within matriarchal groups, adopt orphaned young, and cooperate in defense against predators. These social structures are maintained through touch, synchronized movement, shared vocalizations, and cooperative behaviors, reflecting an emotional and cognitive complexity that parallels some of the deepest social systems observed in humans and other intelligent species. Whales also demonstrate remarkable memory and recognition of individual humans, distinguishing between familiar and unfamiliar people based on visual, vocal, and behavioral cues. In the wild, gray whales have been observed approaching specific boat operators with whom they have had positive interactions while avoiding others, highlighting selective long-term memory and social intelligence. In addition to their social and cognitive abilities, whales exhibit extraordinary physiological traits that support their survival. Their flippers, while externally adapted for aquatic life, contain bones arranged similarly to human hands, allowing fine control of movement, precise steering, and stabilization while swimming, hunting, or playing. Heat regulation occurs through countercurrent blood flow in extremities, allowing whales to move between thermal extremes while conserving energy, and their respiratory efficiency enables rapid oxygen exchange in mere seconds, supporting extended dives and rapid recovery at the surface. Whales' internal chemistry and physiology function as an automatic dive computer, regulating oxygen use, heart rate, and blood distribution to vital organs while tolerating high levels of carbon dioxide and lactic acid during extended dives. Taken together, these traits, the sophisticated respiratory system, the powerful and efficient propulsion mechanism, the thermal regulation, the deep social bonds, the advanced communication, and the ongoing evolution, paint a portrait of a species extraordinarily adapted to its environment. Whales are simultaneously powerful, intelligent, social, and sensitive, able to navigate the oceans with precision, endure extreme conditions, communicate across vast distances, and form enduring social networks. From tail-first bursts to the whispers of calves, from cultural songs to evolutionary adaptations in response to human activity, whales demonstrate the seamless integration of anatomy, behavior, cognition, and environment. Their lives are a testament to the intricate balance of evolutionary pressures and ecological interactions that shape every breath, every dive, every migration, and every social interaction, illustrating how one of Earth's most massive creatures is also among its most sophisticated and resilient, perfectly engineered for survival in a complex, dynamic, and ever-changing ocean world. Whales communicate in ways that humans are only beginning to understand, often using low-frequency sounds that travel vast distances with minimal energy loss, making them ideal for long-range communication across the ocean. Scientists believe these infrasonic calls allow whales to locate mates, coordinate migrations, or maintain social cohesion even in the murky, lightless depths where vision is limited and sound becomes the dominant sensory tool. The ocean is a cacophony of sound, much of it imperceptible to humans, yet whales navigate and interact within it, their calls forming intricate and enduring choruses that have echoed for centuries, revealed only recently through underwater listening stations that capture what has long been hidden beyond human perception. The feeding habits of whales further demonstrate their ecological dominance and specialized adaptations. Blue whales, the largest animals on the planet, consume nearly 4 tons of krill daily during feeding season, swallowing up to 80 million rice-sized crustaceans in a single day. To accomplish this, they lunge into dense swarms of krill with their mouths wide open, expanding their throats like parachutes to engulf volumes of water exceeding the size of their own bodies, then filtering the water through baleen plates to retain their prey. Even young blue whales require enormous quantities of nutrient-rich milk to support their rapid growth, gaining more than 200 pounds per day while nursing, illustrating the intense energy demands of these leviathans and their pivotal role in redistributing nutrients and influencing entire marine food webs. The predatory life of some whales is equally dramatic, with sperm whales engaging in deep-sea hunts for giant squid, often returning to the surface bearing circular scars on their heads and faces that match the suction cups of squid tentacles. These scars serve as evidence of fierce underwater battles in total darkness, with male sperm whales typically displaying the most, a testament to their dominance and survival skills in abyssal ecosystems where giant squid can grow over 40 feet long. The death of a whale, however, is not merely an end but a profound ecological transformation. When a whale sinks to the ocean floor, it becomes the foundation of a complex and enduring ecosystem known as a whale fall, providing food and shelter for hundreds of deep-sea species in an environment where resources are scarce. Scavengers such as hagfish and sleeper sharks consume the soft tissue first, followed by smaller organisms feeding on leftover fat, skin, and bone. Specialized bacteria eventually decompose the bones themselves, releasing sulfides and nutrients that support worms, clams, and other organisms for decades, sometimes exceeding 50 years, effectively creating a miniature deep-sea forest. Certain species are found only in these whale fall ecosystems, highlighting the critical role whales play in shaping biodiversity long after death, turning a single carcass into a vibrant hub of life and demonstrating that whales influence oceanic ecosystems on scales far beyond their own lifetimes. Whales are also ingenious hunters while alive, employing advanced techniques such as bubble net feeding. Humpback whales, for example, create rings or curtains of bubbles around schools of fish, forming a shimmering trap that drives the prey into a tight cluster, which the whales then swim through with open mouths, engulfing thousands of fish in a single lunge. This behavior is not instinctive but learned and coordinated, with multiple whales assuming specific roles in the hunt. Some encircle the fish while others dive or produce sound to further confine the prey, showcasing teamwork, strategy, and the transmission of cultural knowledge across generations. Beyond their ecological and social intelligence, whales bear physical traces of their evolutionary history. Deep within their bodies are vestigial structures, such as tiny kneecap bones, remnants of their land-dwelling ancestors that walked on four legs. These skeletal relics serve as a window into the past, revealing the dramatic transformations over millions of years that allowed whales to transition from terrestrial mammals to masters of the oceans. These adaptations, from anatomy to behavior, demonstrate an intricate and ongoing evolutionary process, as whales continue to adjust to shifting ocean conditions, prey availability, and the impacts of human activity. Some species are showing genetic changes related to immunity, metabolism, and sensory perception, including shifts in body size, hearing sensitivity, and dietary specialization, highlighting that evolution is not static but a continual response to environmental pressures. Whale physiology is equally remarkable, with adaptations that allow them to survive extreme depths, prolonged fasting, and long-distance migrations. Their blood chemistry functions like a natural dive computer, storing oxygen in muscles and tissues, tolerating high carbon dioxide levels, and regulating heart rate and blood flow to vital organs during dives. Specialized proteins such as myoglobin provide oxygen reserves in muscles, while non-essential areas of the body receive reduced circulation, ensuring that the brain and heart remain oxygenated. These internal mechanisms, operating automatically and with exquisite precision, allow whales to dive thousands of feet into crushing pressures and return safely, demonstrating a level of biological engineering unmatched in the terrestrial world. Their respiratory systems are similarly optimized, allowing whales to exchange up to 90% of their lung capacity in a single breath, efficiently replenishing oxygen and minimizing surfacing time, which is crucial for avoiding predators and sustaining long-duration dives. Thermal regulation is managed through countercurrent heat exchange in extremities, allowing whales to navigate freezing waters and warm surface layers without excessive energy expenditure. This combination of speed, endurance, physiological control, and thermal adaptability ensures that whales can inhabit virtually every marine environment, from Arctic ice edges to tropical coral reefs, demonstrating both ecological flexibility and evolutionary resilience. Socially and cognitively, whales exhibit behaviors indicating high intelligence, emotional depth, and complex culture. Orcas and other dolphin-like whales form enduring social bonds that persist for years, cooperating in hunting, adopting orphan calves, and maintaining hierarchies within pods. Sperm whales live in matriarchal clusters, defending young collectively and engaging in coordinated social behaviors that enhance survival. Memory and recognition are profound, with whales distinguishing individual humans and remembering prior interactions, demonstrating selective social cognition that extends to both conspecifics and other species. Communication is equally sophisticated, from whispered calls of humpback calves to avoid predators to the deep, infrasonic songs of adult blue and fin whales, which can travel hundreds of miles and maintain social cohesion over vast distances. Some species perform duet singing, synchronizing vocalizations with remarkable precision, indicating both auditory awareness and cultural transmission of learned behaviors. Male humpbacks sing elaborate, evolving songs for courtship and social purposes, which spread through populations like cultural waves, underscoring the interplay of learning, memory, and social interaction in their communication systems. Reproduction and early development reflect the extreme precision of evolutionary adaptation. Whale calves are often born tail first, ensuring immediate access to the surface for breathing and reducing the risk of drowning, while also minimizing the chance of entrapment in the birth canal. Even from birth, calves must rapidly develop swimming ability and coordination to keep pace with migrations and survive in predator-rich waters. Maternal care is intensive, providing warmth, protection, and nutrient-rich milk to sustain rapid growth, sometimes exceeding 200 pounds gained per day in blue whale calves, emphasizing the extraordinary energy demands and biological investment required for early survival. The dietary and predatory behaviors of whales continue to shape ocean ecosystems. Blue whales' massive krill consumption influences nutrient cycles and redistributes biomass across regions, while sperm whales' predation on giant squid reveals the hidden dynamics of the deep ocean. Bubble net feeding in humpbacks exemplifies learned, cooperative hunting strategies that are culturally transmitted, highlighting the intelligence and adaptability of these animals. Even after death, whales continue to sustain life, creating unique deep-sea ecosystems through whale falls, which can last for decades and support organisms found nowhere else, further demonstrating their integral role in marine biodiversity. Ultimately, whales are living embodiments of evolutionary excellence, integrating anatomy, physiology, behavior, cognition, and culture into a single organism exquisitely adapted to the marine environment. From the deep infrasonic songs that connect populations across ocean basins to the cooperative hunting strategies and maternal care of calves, whales display a combination of physical prowess, social intelligence, ecological influence, and evolutionary adaptability that is unparalleled in the natural world. They demonstrate how life can achieve incredible complexity and resilience, navigating a vast, dynamic, and often hostile ocean with precision, foresight, and social sophistication, illustrating the extraordinary breadth and depth of adaptation and survival in one of Earth's most remarkable creatures. Though modern whales no longer possess external hind limbs, the presence of small internal bones within their bodies serves as a striking reminder of their evolutionary history, tracing back more than 50 million years to when the earliest whales were small hoofed mammals that hunted along riverbanks and walked on land. Over countless generations, these ancestors gradually adapted to life in water, their legs transforming into flippers, bodies elongating and becoming streamlined for efficient swimming, and hips shrinking to near invisibility. Evolution, however, is rarely a perfect eraser of the past. These vestigial bones, though functionless today, act as living fossils, fragments of history preserved within a creature wholly adapted to the marine environment, underscoring that whales are as much products of ancient terrestrial life as they are masters of the ocean. Vision in whales is similarly a testament to adaptation, allowing them to navigate and hunt in near total darkness at depths where sunlight vanishes within mere hundreds of feet. Their retinas are densely packed with rod cells, far more sensitive to faint light than cone cells, and many species possess a reflective layer behind the retina called the tapetum lucidum, which effectively doubles the efficiency of available light by bouncing it back through the photoreceptors. Whales' pupils can dilate dramatically to capture every photon, and their spherical eyeballs maintain focus in both the bright, reflective surface waters and the pitch-black depths of the ocean. While these adaptations compromise color vision, they enable exceptional detection of movement and shapes, a vital capability for survival in the deep sea where prey, predators, and obstacles must be sensed without relying on color. Equally remarkable is the individuality of each whale, embodied in the unique patterns on the underside of their tails, known as flukes. Each fluke bears a combination of scars, pigmentation variations, notches, and natural scratches that are unique to that individual, functioning much like human fingerprints. Scientists exploit this natural identification system by photographing whale flukes and using these images to track individual whales over decades, revealing not only migration paths and breeding behavior but also changes in population dynamics over long periods. Some whales have been documented more than 30 years apart, allowing researchers to observe the full arc of a whale's life, from youth to maturity, through these visual records. This non-invasive method of study has been invaluable for conservation, allowing scientists to monitor populations without disturbing them, and it emphasizes the depth of information that a single whale can convey through subtle physical markings accrued over a lifetime. In addition to visual memory, whales possess extraordinary spatial intelligence, navigating vast ocean expanses with precision that surpasses even our technological mapping capabilities. Gray whales, humpbacks, and other species are known to return reliably to the same underwater valleys, canyons, and ridges year after year, demonstrating an uncanny ability to remember complex three-dimensional underwater landscapes despite strong currents, low visibility, and shifting environmental conditions. Evidence suggests they combine memory with magnetic sensing, pressure detection, and acoustic cues to form mental maps of the seafloor, using reflected sound to sense the contours of underwater formations and adapting their routes to align with ancient seabed features that guided their distant ancestors. This navigational expertise allows them to traverse thousands of miles during migrations, often across open ocean where no visual landmarks exist, relying on an internal sense of direction and location honed through evolutionary time and reinforced by repeated journeys. The biology and behavior of whales exemplify a remarkable integration of form and function across multiple scales of adaptation. Internal skeletal remnants illustrate their terrestrial ancestry, specialized eyes facilitate life in extreme depths, and unique fluke patterns encode information about individual identity and life history. Their cognitive and sensory capabilities, combined with sophisticated navigation and social behaviors, reveal a level of intelligence and environmental attunement that few other species possess. Whales demonstrate an extraordinary synthesis of evolutionary history, anatomical specialization, and ecological mastery. They are living archives of the past, acute observers of their environment, and skilled navigators of the ocean's vast and complex terrain, seamlessly blending heritage, adaptation, and survival into a single, cohesive organism that continues to thrive across the world's oceans while retaining the traces of its ancient, land-dwelling origins. Their existence embodies the power of natural selection to shape life across eons, producing creatures capable of perceiving and interacting with environments that humans can barely imagine, and showcasing the ongoing dialogue between an organism and its habitat, in which survival, memory, and adaptation are inextricably intertwined, each whale a moving testament to the intricate, patient artistry of evolution itself. Whale migration routes are extraordinary in that they do not rely on visual landmarks but instead seem to be encoded in the ocean itself, suggesting that some species may carry mental maps of the seafloor, knowing its ridges, valleys, and contours with an intimacy that surpasses our own understanding of the underwater world. Orcas, or killer whales, exemplify another remarkable aspect of cetacean intelligence: their ability to teach and learn complex hunting strategies. In certain regions, orcas have developed the technique of flipping sharks upside down to induce tonic immobility, temporarily paralyzing the shark so the whale can safely extract its nutrient-rich liver. This behavior is not instinctive. Young orcas acquire it by observing older pod members, and it spreads culturally, demonstrating that orcas possess not only intelligence but also a form of social learning akin to human teaching. Their culture adapts to environmental conditions. As prey availability shifts, new strategies emerge, and knowledge is passed down like a living inheritance, reinforcing the idea that these animals are as much social learners as they are predators. Despite centuries of study, whales continue to reveal new secrets, including species previously unknown to science. Recent discoveries such as Rice's whale in the Gulf of Mexico, initially mistaken for a different species until DNA analysis confirmed its uniqueness, highlight the vast unexplored regions of the ocean and the possibility that large mammals remain undetected in remote or deep water habitats. In some cases, unknown species are inferred solely from previously unrecorded vocalizations captured by deep-sea microphones, and skeletal remains recovered from ocean depths continue to challenge our taxonomic knowledge, underscoring the ocean's role as a frontier where massive creatures can remain hidden from human observation. Whales' auditory capacities are astonishing, allowing them to recognize the echoes of their own songs over vast distances, a form of biological sonar that functions on a planetary scale. These long, low-frequency calls reflect off underwater formations, enabling whales to perceive distance, depth, and spatial positioning without visual cues, effectively creating a mental acoustic map of their environment. Such abilities highlight the critical role of sound in the ocean, where vision is often secondary and acoustic perception becomes essential for navigation, communication, and survival. Humpback whales display another layer of sophistication in cooperative hunting. During bubble net feeding, whales encircle fish with rings of bubbles, corralling prey into dense clusters. Remarkably, they also coordinate attacks silently, using body movements, orientation, and timing to herd fish without producing sound. This silent synchronization suggests whales can detect subtle water pressure changes or vibrations, allowing precise coordination akin to a three-dimensional team sport guided by an unspoken rhythm, demonstrating that whale communication extends far beyond audible calls. Long migrations further test the limits of whale physiology and endurance, as many species fast for months while traveling thousands of miles between nutrient-rich feeding grounds and breeding areas. Gray whales, for instance, feed intensively in the Arctic during summer to build thick blubber reserves, then swim over 5,000 miles south to tropical breeding waters without feeding, relying entirely on stored fat to supply energy, water, and thermoregulation. Such feats require extraordinary metabolic adaptations, including the ability to tolerate high levels of carbon dioxide and lactic acid, store oxygen in muscle and blood, and precisely regulate heart rate and blood flow to prioritize vital organs during extended dives. Their capacity for sustained swimming at impressive speeds ensures that even young calves can keep pace with pods during migration, highlighting the evolutionary refinement of muscle structure, cardiovascular efficiency, and locomotor coordination. Whales' hunting strategies also illustrate their intelligence and problem-solving skills. Blue whales consume up to 4 tons of krill daily, lunging through massive clouds of prey, filtering them through baleen plates while expelling water, and demonstrating a feeding method that is both mechanically efficient and energetically optimized. Sperm whales face equally dramatic challenges hunting giant squid in deep, dark ocean regions, often acquiring scars from the squid's tentacles in battles that testify to the risks involved in deep-sea predation. Such encounters reveal not only the whale's physical adaptations for depth and pressure but also the harsh realities of life in the abyss, where sensory acuity, strength, and strategy converge in predator-prey dynamics. Beyond their immediate survival, whales also play a crucial ecological role after death, creating whale falls, when their carcasses sink to the seafloor, becoming foundations for complex, long-lasting ecosystems. Scavengers such as hagfish and sleeper sharks consume soft tissues first, followed by smaller organisms feeding on remaining fat, skin, and bone, and specialized bacteria gradually break down the skeleton, releasing nutrients like sulfide that support communities of worms, clams, and snails. These whale fall ecosystems can persist for decades, and many species found in these habitats are exclusive to them, demonstrating how whales shape ocean biodiversity even in death. The anatomy of whales further underscores their evolutionary journey. Vestigial kneecap bones point to terrestrial ancestors, flippers contain the same bone structures as human hands, and their skeletal frameworks enable both precise maneuvering and structural support under enormous body mass. Their eyes are adapted for ultra-low light, with rod cell-rich retinas, reflective tapetum lucidum layers, dilating pupils, and spherical lenses allowing them to detect movement and shapes in near darkness. Tail flukes serve as natural fingerprints, unique to each individual, allowing scientists to track migrations, breeding habits, and life histories over decades through non-invasive photographic methods. Additionally, whales demonstrate extraordinary social complexity, forming long-lasting bonds, cooperative hunting groups, and intricate cultural behaviors that include song learning, duet performances, and the transmission of hunting techniques across generations. Infrasound communication allows them to transmit signals across hundreds of miles, connecting populations across entire ocean basins, and even detecting echoes of their own calls to perceive spatial relationships on a scale unimaginable to humans. This sophisticated sensory, social, and ecological network illustrates that whales are not only biological marvels but also integral components of marine ecosystems, capable of shaping environments, influencing prey populations, and sustaining biodiversity. Their migratory endurance, deep diving physiology, acoustic mastery, hunting intelligence, and social learning exemplify an intricate interplay between evolution, behavior, and ecology, revealing animals finely tuned to the ocean's challenges while maintaining connections to an evolutionary past rooted in terrestrial life. From teaching each other to hunt sharks to coordinating silent attacks during group feeding, from navigating the seafloor without visual cues to enduring months without food during migrations, whales exhibit intelligence, adaptability, and culture that rival that of many terrestrial mammals. Humpback whales, like many other species, can fast for extraordinary periods, sometimes exceeding 4 months during migrations, demonstrating not only remarkable endurance but also highly efficient energy utilization. This survival strategy relies on dense, slow-burning fat, or blubber, which supplies all the energy, hydration, and thermoregulation needed until the whale reaches waters abundant with prey, revealing that migration is a careful balance of biological optimization, timing, and risk assessment rather than mere movement across the oceans. Their anatomy supports equally impressive feats of sound production, as the largest whales possess larynxes so enormous that a human could theoretically fit inside, allowing them to generate calls capable of traversing entire ocean basins. These vocalizations are produced not by the vibration of vocal cords like in humans, but through specialized folds of tissue within the larynx, muscular chambers, and the recycling of air internally, enabling continuous underwater singing without compromising buoyancy or energy. Such control allows whales to manipulate pitch, volume, and rhythm with exquisite precision, effectively using their larynxes as giant musical instruments, integral to their communication, courtship, defense, and exploration. Whales' skin, continuously exposed to salt water and friction, peels and regenerates in large sheets, unlike the small-scale shedding seen in humans. This process not only removes dead layers but also helps maintain hydrodynamic efficiency, reduce infection risk, and eliminate parasites. Belugas may rub against riverbeds to accelerate shedding, while other species rely on the motion of the sea, and this renewal occurs multiple times yearly without the whale needing to pause, illustrating the seamless integration of survival adaptations with daily activity. These creatures thrive in some of the coldest waters on Earth, with Arctic and Antarctic seas reaching below the freezing point of fresh water. Their thick blubber acts as insulation, preventing heat loss, while underlying vascular networks manage heat exchange efficiently, allowing warm blood to heat cooler blood returning from extremities, and their heart rate slows in frigid conditions to conserve energy and oxygen. Such adaptations enable whales to swim comfortably in temperatures that would be lethal to most terrestrial animals, transforming inhospitable environments into regular migration routes, feeding grounds, and breeding areas. Beyond physiological resilience, whales also host complex ecosystems on their skin, where barnacles, algae, diatoms, copepods, and numerous other organisms attach, sometimes totaling over 100 species on a single individual. These hitchhikers are transported across thousands of miles annually, spreading genetic diversity, providing indicators of ocean conditions, and benefiting from mobility and shelter, while the whale experiences minimal advantage aside from some increased drag. The intricate interconnection between whale biology, their microbiome, and the environment reflects how these animals are both sculpted by and contributors to the marine ecosystem, highlighting their role as keystone species. Their feeding strategies exemplify further adaptations to ecological challenges. Humpbacks, blue whales, and other baleen species consume immense quantities of prey, with blue whales ingesting up to 4 tons of krill daily, lunging into massive swarms and filtering them through baleen plates while expelling water, demonstrating mechanical efficiency and energetic optimization. Deep-sea predators like sperm whales confront equally formidable challenges hunting giant squid, often returning with scars that testify to encounters with tentacles and beaks, offering glimpses into predatory dynamics in complete darkness. Even death contributes to ecological function through whale falls, where carcasses descend to the seafloor, establishing nutrient-rich foundations for decades-long ecosystems, sustaining scavengers, invertebrates, and bacteria, some species uniquely adapted to these environments, showing how whales impact biodiversity even posthumously. Evolutionary history is embedded in their anatomy. Vestigial kneecaps, flipper bones, and other remnants trace back over 50 million years to terrestrial ancestors that hunted along riverbanks, illustrating the slow transformation from hoofed mammals to fully aquatic giants. Sensory adaptations complement these physical features, with eyes optimized for low-light vision through rod cell-rich retinas, reflective tapetum lucidum layers, adjustable pupils, and spherical lenses, granting the ability to detect shapes and motion in near darkness, critical for hunting and navigation in deep waters where sunlight cannot penetrate. Each whale's tail fluke functions as a biological fingerprint, with unique markings, scars, and pigmentation enabling researchers to track individuals and study migration, breeding patterns, and population dynamics over decades, making non-invasive monitoring possible. Whales' remarkable spatial awareness is further enhanced by potential mental maps of the seafloor, allowing navigation through underwater valleys, ridges, and ancient sea paths using a combination of sound, magnetism, and pressure detection, independent of surface visible landmarks, suggesting some species may know portions of the planet better than humans. Orcas exemplify cultural transmission, teaching younger individuals complex hunting techniques like inducing tonic immobility in sharks to access nutrient-rich livers, a learned behavior that spreads socially and adapts according to environmental prey availability, highlighting the capacity for intelligence, observation, and innovation within social groups. Even today, new whale species continue to be discovered, such as Rice's whale in the Gulf of Mexico, previously misidentified until genetic analysis confirmed its distinctiveness, and unknown species are sometimes inferred solely through unique vocalizations detected in deep waters, emphasizing the vast unexplored nature of the ocean. Whales communicate across immense distances using infrasound, with calls traveling hundreds of miles and allowing them to recognize echoes of their own songs reflected off underwater formations, effectively constructing acoustic maps of their surroundings, a sensory sophistication that surpasses human capabilities. Humpbacks, in particular, demonstrate silent cooperative hunting, coordinating movements, body orientation, and timing to herd prey into dense formations without vocalization, suggesting the ability to detect water pressure changes and subtle vibrations for precise three-dimensional teamwork. Their migratory endurance relies on the strategic use of fat reserves, precise energy management, and extraordinary cardiovascular and respiratory adaptations, including oxygen storage in muscles and blood, heart rate reduction during dives, and selective blood flow prioritization to vital organs, forming an instinctive biological dive computer refined over millions of years of evolution. These capabilities allow whales to dive for hours, traverse thousands of miles, and maintain communication, navigation, and social coordination while submerged in extreme conditions. Reproductive and early life strategies also reflect these evolutionary refinements. Many calves are born tail first to reduce the risk of drowning, remain close to their mothers while whispering soft vocalizations to avoid predation, and gain the ability to swim rapidly within weeks, demonstrating that survival instincts and physical adaptations are present from birth. Additionally, baleen structures have historically supported human industries, with whale baleen, composed of keratin, being used for corsets, umbrellas, and carriage frames before synthetic materials emerged, illustrating the interplay between whale biology and human economic history. Whales' respiratory systems exemplify extraordinary efficiency, exchanging up to 90% of lung air per breath, storing oxygen in specialized proteins like hemoglobin and myoglobin, collapsing lungs safely under pressure to avoid decompression sickness, and replenishing oxygen with brief surface intervals, all of which facilitate extended dives and migration. Thermoregulation is achieved through vascular countercurrent systems, particularly in flippers, flukes, and dorsal fins, allowing whales to release excess heat or conserve warmth without energy expenditure, enabling movement between tropical and polar waters. Swimming mechanics are optimized for speed and efficiency, with up and down tail movement generating powerful thrusts, allowing some species to reach speeds exceeding 30 miles per hour, vital for prey capture, predator evasion, and long-distance travel. Social complexity is profound. Whales form long-lasting bonds, matriarchal family units, and cooperative hunting pods. They transmit knowledge, maintain friendships through touch, movement, and vocal communication, and exhibit behaviors resembling play, mourning, and cultural inheritance, all of which indicate cognitive sophistication rivaling that of terrestrial mammals. Evolution continues to shape whales, as gene selection adapts populations to shifting food sources, noisy oceans, and climate change, subtly altering body size, metabolism, hearing sensitivity, and foraging strategies to ensure survival in an ever-changing environment. Feeding techniques such as bubble net hunting demonstrate learned, cooperative strategies where whales manipulate air, sound, and movement to concentrate prey, revealing ingenuity and transmission of knowledge across generations. Whales' life cycles impact the ocean at multiple scales, from nutrient redistribution through feeding to long-lasting deep-sea ecosystems formed post-mortem, illustrating their role as ecosystem engineers. Scars from encounters with giant squid provide evidence of predation pressures and survival in extreme depths, revealing behaviors previously invisible to human observation. Across their physiology, behavior, and social organization, whales embody an extraordinary integration of evolutionary history, environmental adaptation, sensory and cognitive sophistication, and ecological influence, making them not only apex marine species but also key drivers of oceanic biodiversity, connectivity, and resilience. From the earliest hoofed ancestors to the present-day giants navigating, communicating, and teaching across the vast oceans, whales remain living testaments to millions of years of evolution, displaying intricate adaptations in metabolism, respiration, thermoregulation, locomotion, social structure, and sensory perception. They are capable of remarkable endurance, precise navigation, long-distance communication, cooperative hunting, and cultural transmission, while simultaneously supporting ecosystems on their skin, in their prey, and through their eventual decomposition on the seafloor. Their existence emphasizes the interconnectedness of marine life, the complexity of survival strategies in extreme environments, and the ongoing influence of evolutionary processes, all of which continue to inspire scientific exploration, conservation efforts, and a deeper appreciation of these majestic creatures and the oceanic realm they inhabit, revealing a narrative of resilience, intelligence, and ecological significance that spans millions of years and stretches across the global seas. The ocean gains an entire traveling habitat in motion with whales, linking otherwise isolated parts of the sea and creating dynamic ecosystems wherever they move, while their eyes serve as instruments of emotional communication, expressing subtle shifts in mood through changes in shape, lid angle, and movement. A calm whale often presents wide, relaxed eyes, whereas an alert or threatened whale narrows or darts its gaze. And mothers frequently maintain eye contact with calves as a form of nurturing and bonding. In captivity, some species demonstrate extended eye contact with humans, suggesting that whales use ocular cues as a form of emotional and social communication. The muscles around the eye are both strong and precise, allowing whales to rotate their gaze without moving their heads, detect emotion in conspecifics, and maintain social cohesion, particularly in low light or murky waters where vocalizations alone may not suffice. Their hearing is equally extraordinary, capable of detecting sounds from hundreds of miles away, with baleen whales such as blue, fin, and humpback whales able to perceive low-frequency infrasonic calls traveling through the deep sound channel, a natural layer in the ocean that transmits sound with minimal energy loss, enabling communication over entire ocean basins and facilitating mate location, predator avoidance, and navigation in a largely unseen world. Toothed whales, including dolphins and orcas, complement this with high-frequency echolocation clicks, using specialized skull structures that act as acoustic mirrors, allowing precise detection of objects, prey, and environmental features, effectively replacing vision with a form of spatial intelligence adapted to the ocean's darkness and vast distances. Orcas display remarkable cultural intelligence, employing coordinated hunting techniques such as flipping ice floes to dislodge seals into the water, requiring precise teamwork, timing, and the observation of younger individuals learning from elders, illustrating the transmission of learned behaviors and advanced problem-solving abilities within pods. Feeding strategies of whales are similarly extreme and adaptive. Blue whales can consume up to 4 tons of krill daily during peak feeding, and humpbacks accumulate layers of blubber by consuming krill and small fish in polar waters, enabling them to endure long migrations without food. Even young calves gain hundreds of pounds daily while nursing on nutrient-rich milk, reflecting the species' evolutionary adaptations to episodic feast and famine cycles, which also influence nutrient redistribution in marine ecosystems. Whales' skin records their life histories as a living tapestry of scars from playful interactions, predation, and encounters with anthropogenic threats. These scars, sometimes hidden beneath barnacles, algae, or loose skin, serve as unique identifiers for individuals, helping scientists track social behavior, aggression, and population dynamics over time. Hydration is managed entirely through metabolic processes, as whales derive all necessary water from prey and the conversion of fat into energy during extended periods without drinking, allowing months-long migrations without surfacing for fresh water. Whales' swimming capabilities include backward movement and on-the-spot turning, facilitated by muscular and skeletal adaptations, while their larynxes, so large they could contain a human, allow powerful vocalizations recycled internally to maintain buoyancy and energy efficiency. Their skin regenerates in sheets, shedding dead layers to reduce drag, remove parasites, and maintain hydrodynamic efficiency, with blubber layers providing insulation in waters colder than ice, coupled with vascular networks and heart rate modulation to conserve energy and retain warmth. Whales host entire microecosystems on their skin, including barnacles, algae, diatoms, and copepods, which ride currents and disperse genetic material across vast distances, revealing oceanic conditions and providing researchers with insights into climate and migration. Evolutionary adaptations continue to shape these animals, from vestigial bones evidencing terrestrial ancestry to deep-sea sensory adaptations such as rod-rich retinas and tapetum lucidum layers that allow low-light vision, and tail flukes uniquely patterned like fingerprints to facilitate long-term identification. Whales' navigation demonstrates potential mental mapping of the seafloor, combining memory, geomagnetism, and auditory cues to traverse underwater valleys, ridges, and ancient migration pathways, independent of surface landmarks, while cultural behaviors, such as learned hunting strategies among orcas, showcase intelligence, social learning, and innovation. Whales' life histories also include interactions with predators like giant squid, leaving scars that provide rare insight into deep-sea predatory behavior, and their post-mortem contributions, in the form of whale falls, sustain decades-long ecosystems on the seafloor, enriching biodiversity and serving as foundations for scavengers, invertebrates, and bacteria, some found nowhere else. Reproductive and developmental strategies include tail-first births to reduce drowning risk, rapid early swimming development, and mother-calf vocal communication, demonstrating an integration of behavioral and physical adaptations from birth. Baleen, composed of keratin, historically supported human industries before synthetic alternatives, reflecting the intersection of whale biology and human exploitation. Respiratory adaptations, including oxygen storage in muscles and blood, selective circulation to vital organs, and controlled heart rates, enable extended dives, migration, and complex underwater behavior. Thermoregulation through blubber and vascular countercurrent systems permits movement across extreme thermal gradients, while swimming mechanics optimize energy-efficient propulsion. Social structures are complex, with long-term familial bonds, cooperative hunting, play, mourning, and cultural transmission, highlighting cognitive sophistication. Evolutionary pressures continue to shape whales, adjusting feeding strategies, body size, hearing sensitivity, and metabolism in response to shifting food availability, climate change, and human impacts, ensuring survival in dynamic marine environments. Feeding techniques like bubble net hunting demonstrate learned cooperation, strategic use of air and movement, and intergenerational knowledge transfer. Scars, baleen, blubber, vocalizations, echolocation, and metabolic adaptations all integrate to form a cohesive set of biological and ecological strategies enabling whales to survive, thrive, and influence marine ecosystems on scales ranging from microhabitats on their skin to ocean-wide nutrient redistribution. Collectively, these attributes illustrate whales' extraordinary endurance, precision navigation, long-distance communication, cooperative hunting, cultural learning, ecological engineering, and evolutionary heritage, reflecting millions of years of adaptation to the ocean's physical and biological challenges. Their existence demonstrates the interconnectedness of marine life, the sophistication of survival strategies in extreme environments, and the ongoing impact of evolution, highlighting whales as apex species, keystone ecological agents, and subjects of scientific fascination. Through their migration, feeding, social behavior, sensory sophistication, and reproductive strategies, whales maintain both the stability and diversity of marine ecosystems while continuing to adapt to environmental pressures. They carry the legacy of terrestrial ancestry in vestigial bones, utilize advanced sensory and cognitive abilities to navigate and interact with the environment, teach and learn socially, and contribute to oceanic nutrient cycles in life and death. Whales' influence extends beyond immediate survival, shaping microbial, invertebrate, and vertebrate communities through skin-associated ecosystems, predatory interactions, and post-mortem resource provisioning, reinforcing their central role in global marine biodiversity. Their behaviors, ranging from echolocation and infrasonic communication to cooperative hunting and silent coordination, demonstrate an intelligence finely tuned to the challenges of the marine environment, while physical adaptations in skin, blubber, respiratory and circulatory systems, vision, and skeletal structures support survival across diverse oceanic conditions. Whales' life history strategies, including extended fasting, rapid juvenile growth, and precise migratory timing, reflect a sophisticated integration of metabolism, thermoregulation, sensory perception, social behavior, and ecological impact, while ongoing evolutionary pressures continue to shape physiological, behavioral, and genetic traits, ensuring resilience and adaptability. In essence, whales are not merely marine animals. They are mobile habitats, ecological engineers, cultural beings, and living records of evolutionary history, whose existence interweaves physical, behavioral, and ecological complexity on scales ranging from microscopic symbionts to ocean-spanning migrations, embodying millions of years of adaptation, intelligence, resilience, and interconnection within the planet's oceans, making them among the most remarkable, influential, and ecologically indispensable creatures on Earth. Whales, despite their enormous size, exhibit surprising agility and precision in movement, using powerful muscles in their flippers and tail to maneuver not only forward but also backward and rotationally, with belugas particularly noted for their ability to bend and flex their bodies in ways other whales cannot, while orcas and pilot whales can rotate midwater and change direction within a few strokes. And humpbacks use their long pectoral fins like rudders, steering with subtle adjustments, enabling navigation through narrow caves, ice channels, and complex seafloor landscapes. Backward swimming may also aid in interactions with calves, feeding events, or delicate surface maneuvers, demonstrating that whales are not merely swimmers but fluid movers in three-dimensional space. Fossil evidence further underscores the extraordinary evolutionary history of whales, as bones hundreds of miles inland reveal that parts of modern continents were once submerged under ocean waters, with entire skeletons of early whales discovered in deserts like the Sahara, displaying legs, hooves, and long skulls resembling wolves more than dolphins. While fossil beds in Chile and Peru indicate mass whale strandings from millions of years ago, long before humans existed, offering insights into the rise and fall of oceans and the transition of whales from land to sea, reinforcing that whale bones on land are a testament to Earth's changing landscapes and the deep history of oceanic life. Whales themselves once inhabited rivers, shallow estuaries, and freshwater systems, with species such as Ambulocetus over 40 million years ago using legs for walking on land while swimming like otters in water, gradually evolving into the ocean giants we see today, though modern whales like belugas and gray whales still venture into estuaries and narrow waterways. Behaviors that echo an ancient legacy preserved in their bones, instincts, and actions, linking present-day marine giants to a long-vanished world beneath rock, sand, and time. In addition to their physical agility, whales display remarkable cultural and vocal adaptability. Humpback whales, for example, can abandon songs they have sung for years, adopting entirely new sequences in what researchers call vocal revolutions, where entire populations replace familiar songs with new ones imported from distant groups, spreading through shared waters via sound alone. A phenomenon akin to human adoption of new music trends and unique in the animal kingdom at a population level. Belugas, dubbed the canaries of the sea, exhibit extraordinary vocal versatility, producing chirps, whistles, clicks, trills, and even tones resembling human speech across a broad frequency spectrum, allowing them to navigate, hunt, socialize, and maintain contact in low-visibility Arctic waters, while calves learn vocal patterns from mothers and other pod members, creating localized vocal cultures that vary between groups and are passed through learning, observation, and practice, reflecting both the cognitive sophistication and social complexity of these whales. The integration of precise physical control, vocal learning, social structure, and historical evolutionary adaptations underlines the whale's capacity to survive and thrive in environments ranging from icy polar waters to complex coastal channels, while their ability to alter songs, innovate hunting strategies, and teach techniques culturally demonstrates intelligence, planning, and flexibility that extend beyond instinctual behavior. Fossil records, combined with the observation of modern behaviors, illustrate a continuity of adaptation over millions of years, highlighting how whales transition from terrestrial ancestors with functional legs to fully aquatic giants, retaining fragments of their evolutionary past in skeletal structures and behavioral tendencies, while their current ecological roles, including migration, feeding, and nutrient redistribution, show how ancient evolutionary strategies continue to shape marine ecosystems. Vocal flexibility, echolocation, cooperative hunting, navigation through mental mapping and auditory cues, as well as physiological adaptations such as blubber for insulation, metabolic water production, and thermoregulation, all integrate to make whales highly efficient, adaptable, and ecologically influential creatures, capable of moving through three-dimensional aquatic space with precision, sustaining themselves during long migrations without food or fresh water, and passing cultural knowledge across generations. Their life histories, encompassing growth, feeding, reproduction, migration, and social interaction, are intricately linked to environmental conditions and evolutionary pressures, with adaptations in anatomy, behavior, and cognition ensuring survival in a world of extremes, from sub-zero polar waters to nutrient-scarce migration routes, while their social structures, learning capacities, and vocal culture reflect a level of intelligence and cultural complexity that is unparalleled among non-human species. Whales' physical capabilities, agility, maneuverability, precise swimming control, and skeletal adaptations complement their behavioral sophistication, including learned hunting techniques, silent coordination in group feeding, and rapid vocal learning, allowing them to interact with their environment and each other in ways that profoundly affect ecological processes. From the distribution of prey to the shaping of deep-sea communities, and from facilitating microecosystems on their skin to influencing nutrient cycles through feeding and whale falls. These marine giants, through a combination of physical power, sensory precision, cultural learning, evolutionary heritage, and ecological impact, exemplify a synthesis of biological, behavioral, and environmental adaptation, reflecting millions of years of evolution that have enabled them to navigate, communicate, and thrive in complex and extreme marine habitats while maintaining their roles as apex species, ecological engineers, and cultural beings capable of remarkable innovation, intelligence, and intergenerational knowledge transmission. Their interactions with humans, whether through observation, conservation, or historical exploitation, highlight both the vulnerability and resilience of these creatures, while ongoing research continues to uncover new species, previously unknown behaviors, and insights into the cognitive and ecological sophistication of whales, reaffirming their central role in marine biodiversity, ecosystem function, and the broader narrative of life on Earth, as living records of evolutionary history. Carriers of ancient legacies, and active participants in the dynamic processes that shape the oceans. Some belugas in captivity have demonstrated the remarkable ability to imitate the rhythm of human voices or mimic environmental noises, illustrating not only their advanced vocal flexibility but also a capacity for social engagement and learning, as they adapt sounds to connect with others in their environment, and their constant underwater chatter creates complex, layered acoustic landscapes akin to the richness of a rainforest, highlighting the importance of sound in their social and navigational life. While gray whales exhibit a form of environmental interaction rarely seen in marine mammals by rolling in shallow mud during migrations through coastal lagoons, using sandy or muddy seafloors to exfoliate their massive bodies, removing barnacles and skin parasites acquired during months of feeding in Arctic waters, and in the process stirring up sediment clouds visible from shore that trace their slow rotation through the water, with researchers noting that parasite accumulation is especially pronounced around tails, fins, and heads, and that this ritual serves not only to relieve irritation and maintain healthy skin but also leaves markings used to identify individuals and assess parasite loads, making gray whales one of the few species known to employ the ocean floor as a natural grooming tool. The evolutionary history of whales underscores the incredible transformation from terrestrial to aquatic life, with ancient ancestors more than 50 million years ago resembling wolf-sized land mammals with hooves, sharp teeth, and dense fur, such as Pachycetus, which hunted along riverbanks and still walked on land, and Ambulocetus, which swam like an otter but retained functional legs. With their bodies gradually streamlining over millions of years, nostrils migrating to form blowholes, hind limbs shrinking into vestigial structures hidden beneath the skin, and fur replaced by thick blubber to provide insulation for deeper waters, illustrating that whales did not transition abruptly from land to sea but went through numerous intermediate forms, leaving traces of their evolutionary past in tiny internal bones that persist today. Sperm whales exemplify the extraordinary adaptation of sound for hunting, using the specialized spermaceti organ in their massive heads to produce some of the loudest biological sounds on Earth, generating focused clicks that act like acoustic bullets capable of temporarily disorienting or immobilizing prey such as squid and fish in the pitch-black depths exceeding a mile below the surface, where sunlight does not penetrate, allowing these whales to track and capture fast-moving prey in complete darkness, with sound levels reaching over 200 decibels while remaining narrowly directed and rarely audible above the surface, demonstrating a sophisticated acoustic strategy essential for survival in deep-sea environments. Whales also display the cognitive ability to recognize specific human-made objects, such as whale-watching boats, showing selective behavior toward familiar vessels while avoiding unknown ones, as observed with gray whales in Baja California that approach certain boats for interaction and avoid others, suggesting a combination of visual, auditory, and tactile memory, and an ability to discern subtle differences in shape, engine frequency, and noise, reflecting long-term memory, learning, and individualized behavioral strategies. These behaviors, from vocal mimicry and social communication to environmental grooming and selective recognition, underscore the intelligence, adaptability, and cultural complexity of whales, while their evolutionary trajectory from land-dwelling, fur-covered ancestors to streamlined aquatic giants with internal vestigial bones provides insight into the gradual but profound adaptations required for fully marine life, including the development of blubber for insulation, the migration of nostrils to the top of the head, and the refinement of sensory systems for underwater navigation, hunting, and social interaction. Beyond these physical and behavioral adaptations, whales exemplify ecological interconnectedness, as their feeding, migration, and grooming behaviors redistribute nutrients, shape ocean floor communities, and support symbiotic relationships, such as the diverse microecosystems found on their skin, comprising barnacles, algae, amphipods, and other organisms, which benefit from transport across thousands of miles while influencing water flow and hydrodynamics around the whale, illustrating how a single species can carry and link entire ecosystems as it moves through the ocean. Beluga's vocal versatility, including the production of chirps, whistles, clicks, and tones resembling human speech across a wide frequency range, allows them to navigate, socialize, and maintain contact in murky Arctic waters, creating localized vocal cultures that calves learn from their mothers and pod members, which vary between groups and are passed through social learning, demonstrating both cognitive sophistication and social complexity, while humpback whales exhibit cultural vocal innovation by abandoning long-standing songs and adopting entirely new sequences, a phenomenon known as vocal revolution that spreads across populations over thousands of miles, reflecting an ability to learn, choose, update, and reinvent traditions in a manner that parallels human musical trends, making them unique among non-human species in their capacity for population-level vocal replacement. These forms of communication, combined with precise physical control, cooperative hunting strategies, echolocation, and environmental interaction, highlight the integration of intelligence, social behavior, and ecological adaptation in whales, whose survival depends not only on biological features such as blubber for insulation, efficient heat exchange, and metabolic water production, but also on cultural knowledge, learning, and behavioral flexibility, allowing them to navigate vast oceans, endure long migrations without food or fresh water, and exploit complex environments, while maintaining social cohesion and cooperation. Gray whales' mud-rolling behavior, belugas' mimicry, sperm whales' acoustic hunting, and selective recognition of human vessels illustrate a spectrum of adaptive strategies that are both physiological and cognitive, emphasizing whales' capacity to interact with their surroundings, manipulate their environment, and transmit knowledge, while their evolutionary history connects these behaviors to a lineage of land-dwelling, river-hunting ancestors, whose intermediate forms reveal the incremental transformation of limbs, sensory organs, and body structure over millions of years, leaving modern whales with vestigial bones, instinctual behaviors, and adaptive physiology that serve as living reminders of their terrestrial past. The combination of complex vocalization, social learning, environmental manipulation, physical adaptability, and deep evolutionary heritage paints a picture of whales as highly intelligent, culturally sophisticated, and ecologically influential creatures, capable of shaping their environments and the lives of other species while thriving in extreme and variable conditions, demonstrating a remarkable integration of physiology, behavior, culture, and ecology that underscores their status as apex marine species, evolutionary marvels, and keystone players in oceanic ecosystems, whose life histories, from feeding and migration to social communication and environmental interaction, continue to reveal new insights into the depth of their intelligence. Such behavior challenges the long-held assumption that whales see humans as identical. Instead, evidence suggests they form unique impressions of individual people and boats through repeated encounters, storing information that can last across seasons or even years. These remarkable responses are not automatic but earned, cultivated through patience, respect, and gentle approach by humans who enter the whale's realm. The connection between human and whale is a fragile bridge of trust built slowly across the divide between species. To truly understand these beings, one must look beyond their behaviors to their deep evolutionary origins. The first whales appeared more than 50 million years ago, evolving from small hoofed mammals that roamed the ancient Earth after the extinction of the dinosaurs. During this time, the planet's climate was warm, and shallow seas flooded across continents, creating perfect conditions for life to experiment with new forms. These early proto-whales, collectively known as Archaeocetes, underwent one of the most astonishing transformations in mammalian history. Their noses slid backward on their skulls, preparing to become blowholes. Their forelimbs flattened into flippers, and their hind limbs gradually shrank. Their spines elongated, adapting for powerful undulating strokes through water rather than walking on land. Fossils found in Pakistan and India reveal this gradual process, showing how each evolutionary stage brought whales closer to the aquatic mastery they exhibit today while still retaining traces of their terrestrial past. Over millions of years, whales diverged into two great lineages: toothed whales, Odontoceti, which evolved echolocation for hunting and complex communication, and baleen whales, Mystaceti, which developed immense filtering plates to strain vast volumes of water for krill and plankton. This evolutionary branching was one of the most profound experiments in nature, giving rise to mammals that completely abandoned land, learned to breathe air at the surface, and mastered the immense world of depth, pressure, and sound beneath the waves. Among these descendants, killer whales, or orcas, stand out as symbols of adaptability and intelligence. They are highly observant creatures capable of learning not only through their own experiences but also by watching others. This ability to imitate and innovate places them among the most culturally complex animals on the planet. In the wild, orcas have been observed adopting hunting techniques from other species, such as the tail-slapping methods of humpback whales to stun schools of fish, or mimicking the vocal patterns of dolphins and other predators to lure prey closer. This imitation shows that orcas are not bound by instinct alone. They are creative problem solvers who modify and refine their strategies based on opportunity and social learning. Their behavior is flexible, varied, and deeply intelligent, allowing them to thrive in vastly different environments, from polar ice fields to tropical coral reefs. They are not simply creatures of habit but adaptive thinkers capable of cultural transmission, sharing knowledge, songs, and techniques across generations, much like humans share language and tradition. Whales as a whole inhabit a world ruled by sound rather than light. In the ocean's depths, sunlight fades within a few hundred feet, but sound travels for hundreds of miles. By releasing pulses, clicks, and low-frequency calls, whales build detailed acoustic pictures of their environment. Toothed whales such as dolphins and sperm whales use echolocation, emitting high-pitched clicks and analyzing returning echoes to map the location, size, and density of surrounding objects. This allows them to hunt in complete darkness, recognizing individual fish or squid with astonishing precision. Baleen whales, on the other hand, rely on low-frequency songs that travel across entire ocean basins. These deep, resonant sounds bounce off underwater mountains, coastlines, and trenches, creating a kind of sonic geography. Scientists believe that whales can detect subtle differences in how sound reverberates across these features, enabling them to create internal, sound maps of their world. These maps, built through memory and repetition, allow whales to return year after year to the same breeding and feeding grounds, even after migrations spanning thousands of miles. It is a navigation system rooted not in sight but in sound, an ancient, sophisticated sense that ties them intimately to the rhythm of the sea. Yet beyond their physical and sensory marvels lies something even more profound: emotion. Increasingly, scientists recognize that whales may have emotional lives as vast and deep as the oceans they inhabit. Studies of brain anatomy show that many large whale species possess limbic systems, structures responsible for emotion and memory, that are as complex as those of humans and great apes. This neuroanatomical evidence aligns with observed behavior. Orcas and sperm whales have been seen mourning their dead, carrying the bodies of calves or companions for days, sometimes longer, in silent vigil. Humpback whales have intervened in predator attacks to protect seals and other species entirely unrelated to them, acts that appear to defy traditional notions of self-preserving instinct. Such empathy hints at an emotional intelligence capable of recognizing the suffering of others. Calves, meanwhile, engage in play, breaching, tail-slapping, and rolling through kelp forests, learning through exploration just as human children do, forming attachments that last throughout life. These patterns reveal an emotional world that is vast, layered, and deeply social. Every song, every movement, and every gesture among whales tells a story of connection, to their kin, to their environment, and perhaps even to us. From the low, haunting songs of blue whales that travel thousands of miles through the deep, to the rapid, melodic whistles of dolphins, these creatures communicate across time and space in ways that scientists are only beginning to comprehend. Some humpback whale songs evolve and spread across entire ocean populations, changing annually like cultural trends in human societies. Others remain regionally distinct, passed down from mother to calf, generation after generation. Within these vocal traditions lies evidence of culture, learned, shared, and dynamic patterns of behavior that bind communities together through memory and sound. The story of whales, then, is not only a biological one but a deeply emotional and philosophical narrative. They are living archives of Earth's history, descendants of land mammals that once walked under open skies and now glide silently through shadow depths. Their evolution from creatures with hooves and fur to beings of grace and intelligence mirrors the adaptability of life itself. Whales teach us that survival is not about domination but about transformation, about finding harmony within change. In their migration routes that span hemispheres, In their songs that echo through the dark, and in their social bonds that endure across generations, they remind us of the continuity of life on this planet. When we encounter whales in the wild, when a gray whale surfaces beside a boat or an orca's fin cuts the horizon, we are not simply observing animals. We are meeting fellow sentient beings who perceive the world through senses and emotions profoundly different yet strangely familiar to our own. These encounters can reshape our understanding of empathy, intelligence, and belonging. Whales recognize individual boats and even people, remembering patterns of behavior, returning to vessels that approach respectfully while avoiding those that do not. This selective memory reveals a consciousness capable of discerning trust and danger, of forming impressions and associations that transcend instinct. It reminds us that respect in the natural world is reciprocal. The gentleness we offer is often reflected back. In the quiet pulse of the deep ocean, whales carry entire ecosystems on their skin and entire histories in their bones. Barnacles, algae, and small crustaceans live symbiotically upon them, traveling thousands of miles across the globe. When whales feed at depth and defecate near the surface, they redistribute nutrients that fertilize plankton, fueling the marine food web. Even in death, their sinking bodies, whale falls, create oases of life on the seafloor that sustain unique communities for decades. Every stage of a whale's life contributes to the health and balance of the ocean. As we study them, film them, and share their stories, it is easy to forget that we share this planet with beings who communicate in sound, feel in currents, and remember in songs older than our civilizations. They live in a dimension of experience where light dissolves into darkness, and where sound becomes both language and landscape. In their company, we are reminded of the vastness of existence, the countless forms of intelligence that thrive beyond human sight. The gentle flick of a tail, the echo of a song beneath the waves, the slow dance of migration through the blue, all of it tells us that the ocean is still alive with quiet wonders. And so, as the final note of this journey settles into silence, let yourself breathe deeply. Imagine the calm, steady rhythm of the ocean, the pulse that has carried life for eons. Let your thoughts drift like sunlight filtering through gentle water. Feel the ancient presence of whales beneath you, their songs rising and fading through the depths, whispering of a world where time moves slowly, where memory is carried in waves. Know that as you rest, the ocean continues its endless conversation, alive with motion, with mystery, with life. Somewhere out there, a mother whale guides her calf through moonlit water. Somewhere, an orca sings to its pod. Somewhere, a humpback's song stretches across the miles. The world beneath the waves continues, serene and eternal. So close your eyes, let go of the noise above, and drift into the vast blue calm, knowing that the sea, and the creatures who dwell within it, still breathe, still sing, still dream. Good night.